Hello everyone. So in this one shot, I'm going to discuss kinematics. So we'll see 1D, 2D, relative motion, projectile motion, right? Everything in a single video. So I'm going to discuss more than 20 problem types which can be formed from this chapter, and it's going to be a revision video. So I'm not going to derive any formula, but we'll see application of each and every concept which can be asked in JEE Mains 2025. So without any further delay, let's begin session.
Now first let us see the three problem types that can be formed in position, displacement, velocity and acceleration calculation. So the very first problem type is finding the instantaneous velocity or the instantaneous acceleration, and the second one is the finding the average speed during the entire journey. And then there will be motion in a circular path, and then they can ask us what is the distance covered, what is the displacement, or what is the change in velocity. All these types of question can be asked. Now let us see the very first problem type, finding the instantaneous velocity and the acceleration. So let us see the question. A particle is moving in one dimension under the action of a variable force. Its initial position is 16 meters right to the origin. The variation of its position with time is given by this, right? So x is equals to minus 3t cube plus 18t square plus 16t, where x is in meters, t is in seconds. The velocity of the particle when its acceleration becomes 0. So we have to find the velocity when the acceleration becomes 0. Right, so here what we have to remember, that the instantaneous velocity is nothing but the rate of change of position. So dx by dt will give us instantaneous velocity, and instantaneous acceleration is the rate of change of velocity, dv by dt. And we have to find the velocity when acceleration becomes 0. So what we're going to do in this question, we'll find the instantaneous acceleration, and let us check at what time acceleration is 0. So we'll get the time, then we use that time to find the instantaneous velocity. Let us see. So let us first find the instantaneous velocity. So the differentiation of t cube will be 3t square, differentiation of t square will be 2t, and differentiation of t will be 1. So we can say v is nothing but minus 9t square and plus 36t plus 16. So that is instantaneous velocity. Now if you differentiate again, then the instantaneous acceleration will be minus 18t plus 36, and let us find the time when this acceleration is 0. So when this acceleration is 0, t will be 36 by 18, which is nothing but 2 seconds. Now we got the time when acceleration is 0. Let us substitute this time in the instantaneous velocity formula. So v comes out to be, at t equals to 2 seconds, it will be minus 9 times 4 plus 36 times 2 plus 16. So if we simplify this, so this will be 36 plus 16, that is nothing but 52 meters per second. So 52 is the answer of this question. Now let us see another question based on the same problem type. A particle is moving in a straight line. The variation of x as a function of time t is given as x equals to t cube minus 6t square plus 20t plus 15 in meters. The velocity of the body when acceleration becomes 0. Again, it is based on the same concept, so I'm leaving this as a homework for you. Now you know how to tackle these type of questions. Let us see this question. A particle initially at rest starts moving from a reference point x equals to 0 along the x-axis with velocity v that varies as v equals to 4 times root x in meters per second. The acceleration of the particle is, so we have to find the acceleration, and v is given as a function of position. So v is given as 4 times root x. Now what we're going to do, we'll differentiate this with respect to time. We will get the instantaneous acceleration. So dv by dt equals to 4 is constant, so d by dt of root x. So this will give us acceleration, and dv by dt of root x. So the differentiation of root x with respect to x is 1 by 2 root x. Then we have to apply chain rule, then it will be dx by dt. Now this dx by dt is nothing but the instantaneous velocity. So we can write this as 2 upon root x times v, and instantaneous velocity is given as 4 times root x. So it will be 2 divided by root x, and v can be written as 4 times root x. So root x will get cancelled out, and we are getting 8 meter per second square as the acceleration. So we can say in this case the acceleration is constant, right? So it is 8 meters per second square. Now let us see another illustration based on the same problem type. The distance traveled by the object in time t is given by s equals to 2.5 t square. The instantaneous speed of the object at t equals to 5 seconds. So we have given the distance traveled, or you can say this is also the position, because the distance traveled is 0 at t equals to 0. So we can assume, we can say this s is nothing but the position of the particle. So instantaneous velocity will be ds by dt, which is nothing but 2.5 times the differentiation of t square is 2t. So it comes out to be 5t. And we have to, what is the velocity at t equals to 5 seconds? It will be 25 meters per second. And we know the magnitude of the velocity is speed, so speed is also 25 meters per second. So option 4 is the right answer. Again, it is based on the same concept, so I'm keeping this as a homework for you. You just have to differentiate x with respect to time, you will get the velocity. And then you can substitute t as 2 seconds, you will get the answer. Right, so yeah, again it is based on the same concept. Again, I'm keeping this as a homework for you. Just let me tell you the answer for that. Option 1 should be the right answer in this case, and in this question option 3 should be the right answer. Okay, right, so now let us see the next problem type, which is based on calculating average speed for the entire trip. A person travels x distance with the velocity v1 and then x distance with the velocity v2 in the same direction. The average velocity of the person is v. Then the relative relation between v, v1 and v2. Okay, let me first draw the diagram what we have. So let us say this is AB, which is having a length x, and then we have BC, which is having a length x. Now the particle covers A to B with a speed v1, and it covers B to C with a speed v2. Right, and what is the average velocity for the entire trip? It is nothing but the displacement upon time interval, right? So average velocity will be displacement upon time. So what is the overall displacement? It is nothing but 2x. It is going in the same direction. And what is the time? So we can say it will be sum of the time from A to B plus B to C, right? Now what is time from A to B? From A to B, the particle is moving uniformly with the velocity v1. So the time will be distance upon speed. Distance is x, speed is v1. So we can write this as 2x divided by distance upon speed, and this will be distance upon speed. Now this will give us 2v1 v2 divided by v1 plus v2. So this average velocity is given as v in the question. Now this will give us 2 by v is equals to 1 by v1 plus 1 by v2. So option 3 is the right answer. Now let us see one more illustration based on the same concept. A particle moving in the straight line covers half of the distance with the speed 6 meters per second, and the other half is covered in two equal time intervals with speed 9 meters per second and 15 meters per second respectively. The average speed of the particle during the motion. Okay, let me first draw the diagram. Let us, this is A to B, which is x, and this is B to C, which is again x, right? So from A to B, the particle is covering this x distance with speed 6 meters per second. And let us say from B to C, the time taken is 2t, right? Let us assume that from B to C. So for half the time interval, let us say this is the time interval, that much, right? So this distance is covered, let us say BD, right? So BD is covered with a speed 9 meters per second, and DC is covered with 15 meters per second. So what we can say, B to D time is t and D to C time is t. So we can say x is nothing but speed into time. X is distance is speed into time, right? So it will be 9t plus 15t, right? So this will give us the relation between x and t. Now we have to find the average speed for the entire trip. So average speed is the total distance upon total time. So total distance in this case will be 2x, and the total time will be time from A to B plus time from D to D, B to D plus time from D to C. So this can be written as 2x divided by time from A to B is distance upon speed, which is x by 6, and time from B to D is t, and time from D to C is t. And we know the relation between x and t. So x is nothing but 24 times t. So let us substitute x as 24 times t. So this will become 48 times t, and it will be 24 times t divided by 6 plus 2t. So this will give us 4, and we will get 48 divided by 6, which is nothing but 8. So it will be 8 meters per second. So option 2 is the right answer. Now let us see one more illustration based on the same concept. A car covers AB distance with first 1/3 at a speed of v by v1, and the second 1/3 with v2, and the third last 1/3 with the speed v3 meters per second. And we have given v3 is 3 times v1, v2 is 2 times v1, and v1 is equals to 11. So basically we have given all the speeds, right? So v2 is 22, and v3 is 3 times 11, that will be 33, and v1 is given as 11. So that is given to us. So I can, let us assume that the total distance is 3x. So it covers x distance with v1, x distance with v2, x distance with v3. So if you want to find the average velocity, that will be the total displacement upon total time. So total displacement will be 3x, and the time from, let me call this point as C and this point as D. Time from A to C is distance upon speed, and time from C to D is distance upon speed, and time from D to B is distance upon speed. So x will get eliminated, so it will be 3 divided by 1 by 11 plus 1 by 22 plus 1 by 33. We can take 1 by 11 common in the numerator. So we'll get 3 times 11 divided by 1 plus 1 by 2 plus 1 by 3. So that will be 33 divided by, and the LCM in the denominator will be 6. So 6 plus 3 plus 2. So it will be 33 times 6 divided by 11. So that will give us 3, and it will be 18 meters per second. So 18 is the answer of this question. Right, so I'm keeping this question as a homework for you because again it is based on the same concept. So in this case the option 3 is the right answer. Let us try to do this question. Again we have covered the same question. Like this question is similar to this one, right, which we have covered. So, right, so let me just read out the question and then you can try this question on your own. A horse rider covers half the distance with 5 meters per second speed. The remaining part of the distance was traveled with the speed 10 meters per second for half the time and 15 meters per second for other half of the time. And the mean speed of the rider average of the whole time of the motion is x by 7 meters per second, the value of x, right? It is again the same, only the values are different. Overall the question is same, which is same as this question, right? Okay, if you solve this, you will get 50 as the value of x. Okay, right. So let us see this question. A vehicle travels 4 kilometers with the speed of 3 kilometers per hour and another 4 kilometers with the speed of 5 kilometers per hour. Then its average speed. Okay, so we have given distance and we have given speed. So 4 kilometers and then 4 kilometers. This distance is covered with 3 kilometers per hour, this with 5. So average speed, total distance, that will be 8 kilometers, and the time will be distance upon speed plus distance upon speed. So that will give us 8 times 15 is the LCM, and we have 4 in the denominator, 5 plus 3. So that will give us 2. So 30 by 8, which is 3.75 kilometers per hour. So option 4 is the right answer. Okay, so I'm not doing this question again. It is we have covered the same question. I'm keeping this as a homework, and the answer for this question will be option number 4. Now let us see the third problem type, which is based on motion of the particle in a circular path. A clock has 75 centimeter and 60 centimeter long second hand and the minute hand. So 75 centimeter is the second hand and 60 centimeter is minute hand. In 30 minutes, the duration of the tip of the second hand will travel. The tip of the second hand travel a distance x more than the tip of the minute hand in 30 minutes. The value of x in meters. Okay, let us see. in 30 minutes, the minute hand will cover half the circle, right? So it will cover half the circle. So we can say if the radius is given, so this is nothing but the radius of that circle. Let me show you. So if this is the minute hand, the tip will cover half the circle in 30 minutes. And this radius is 60 centimeter. So this arc length will be pi times 60 centimeter. Whereas in the same time, if you consider second hand, so in 1 minute, second hand completes one full rotation, right? So in 30 minutes, the second hand will cover 30 full rotations, right? So it has covered overall how much distance? The tip of the second hand, it has covered 2 pi r, which is 75 centimeter times 30. And we have to find the value of x in meters. So we have to take the difference of these two, right? So what is x? It is the more distance covered by the second hand in comparison to the minute hand. So it will be 2 pi times 75 centimeter times 30 minus pi times 60 centimeter. And we have to find answer in terms of meters. So let us divide this with 100 so that we can convert this into meters. So pi will be common, and we will get 2 times 0.75 times 30 minus 0.6. Right, so this comes out to be, so this will be 3 by 4. This is 3 and this is 4. So this will give us 7.5. And we have 15 times 3 minus 0.6. So 45 minus 0.6. And pi is 3.14. So we have to find the closest answer. So 3.14 times 44.4. So this will be 139.4. So option 3, 139.4 meters. So option 3 is the right answer. Now let's see this question based on the same problem type. A cyclist starts from the point P of a circular ground of radius 2 kilometers. So radius is given as 2 kilometers. And travels along its circumference to the point S. So it is going in the clockwise direction and it reaches S from the point P while cycling in the clockwise direction. And we have to find the displacement. We know the displacement is the shortest distance between the initial and the final position. So this will be the displacement. And we have to find the magnitude of the displacement. So if you look at this right angle triangle, this is R and this is R, and radius is given as 2 kilometers. So that will be root 2 times R. So it will be 2 root 2 kilometers, or we can write this as root 8 kilometers. So option 1 is the right answer. Now let us see this question. A body is moving with a constant speed in a circle of radius 10 meters. The body completes one revolution in 4 seconds. At the end of third second, the displacement of the body. So if the body covers the complete, if it has a one full rotation revolution in 4 seconds, so in 3 seconds it will be having 3/4 revolution. Again, it is based on the last question. If this is the circular path and the particle starts say from point P and it is moving uniformly, so that will be the 3/4 rotation, right? So it is going like this. So here it will reach in 3 seconds. So the displacement will be this, right? So again, it is R by R root 2. And in this case, radius is given as 10. So that will be 10 root 2. So option 4 is the right answer. So in uniform accelerated motion, there can be around 10 problem types. So let us study these problem types one by one. So the first problem type is based on equations of motion, where you must remember the three formulas: v is equals to u plus at, or s is equals to ut plus half at square, and v square is equals to u square plus 2as. And the second problem type is based on the displacement in the nth second, so that you have to remember in the nth second if the particle is moving uniformly with a constant uniform accelerated, if the particle is having uniform accelerated motion, then it will be u plus a by 2 to n minus 1. Then stopping time and stopping distance, and the stopping distance is given as v square by 2a, where a is the retardation. And stopping time we can find as v by a, that will be the stopping time. Then average speed calculation, that will be the total displacement upon total time. And then we have vertical projection from the height. So if you are projecting something from the height in the upward direction, then the initial velocity, if you take downward as positive, then the initial velocity will be negative. Then vertical projection from the ground, then air resistance in the vertical projection. If we have air resistance, in that case the acceleration in the like when the particle is ascending, the acceleration will be different than when the particle is descending. And then there will be questions where the particle first accelerates and then decelerates and come to rest. We'll see that also. And then there will be a problem type where we consider the penetration of a bullet in a block, and they will ask you up to what distance it will penetrate. Then a body drop from the height. So we'll see all this problem type. Let us see the very first one. Equation of motion. So a body starts moving from rest with a constant acceleration, covers displacement s1 in first p minus 1 second and s2 in first p seconds. The displacement s1 plus s2 will be made in what time? Okay, right. So we have given that the displacement s1. So here I'm going to use which formula? Because time is given and the displacement is given, we can assume that the constant acceleration is a and the initial velocity is 0. So let us use s is equals to ut plus half at square. So I'm going to apply this formula 3 times. First for s1, then for s2, and then for s1 plus s2. So s1 and initial velocity is 0 plus half a p minus 1 square, and then s2 is equals to 0 plus half a p square, and then s1 plus s2 equals to 0 plus half a, let us take the time as t, and we have to find t square. Now from these two equations, right, so we can add these two equations. So we can say s1 plus s2 will be half a times p minus 1 square plus p square, right? So if we compare, now let us compare this equation with this equation. So we can clearly see that t square is equals to p minus 1 square plus p square, and this will be 2p square minus 2p plus 1. So we can clearly see that option 2 is the right answer. Now let us see the next illustration. A small toy starts moving from the position of rest. So initial velocity is 0. Under a constant acceleration, let us say a is the acceleration. If it travels a distance of 10 meters in t seconds, the distance traveled by the toy in the next t seconds. Okay, right. So let us the toy covers a distance a to b in t seconds, and it covers a distance a to c in 2t seconds, right? A to c. So what we're going to do, we'll apply equations of motion between a to b and from a to c, because it is always convenient if one of the state of the particle is at rest. So from a to b, we can say we have to find the distance traveled by the toy in the next t seconds. So we can say from a to b, ab is half a t square, and t square is t square, and from a to c it will be half a 2t square. So that will comes out to be 4 times half a t square. Now what is half a t square? That is nothing but 10. So that is 10 meters. So it will be 40 meters. So the distance covered by the particle from b to c will be 30 meters. So can you see when the particle is released, or you can say when the particle is released from rest and it is moving with a constant acceleration, then the displacement in successive equal time interval will be in odd ratio. So it will be 1:3:5 like this. So in first t second it has covered a displacement 10. So in the next t second, it will cover 30. In the next t second, it will cover 50. So like this, you can remember also. This is also known as a Galileo's law of odd number. Now let us see this question. A particle is moving in a straight line such that its velocity is increasing at 5 meters per second per meter. So we can say dv by dx is given as 5, right? 5 meters per second per meter. The acceleration of particle is, so we have to find the acceleration of particle at the point where the velocity is 20 meters per second, right? So let us try to do this. So dv is given as 5 times dx. Now if we divide both sides with dt, this is nothing but the acceleration and this is nothing but the velocity. So we can say acceleration is 5 times the velocity, and when the velocity is 20, acceleration will be 100. So 100 is the answer, right? Right. So now this question is not from this particular type, right? Because we haven't used any equation of motion. But still remember, like, what we have done. So what we have given in the question, accordingly you have to solve the question. An engine of a train moving with uniform acceleration passes the signal post with velocity u and the last compartment with the velocity v. So what we have given, there is a train. This is the front end and this is the rear end. And let us say this is the signal post, right? That is the signal post. So it is going in the right direction. At this very instant, the velocity is u, and when the rear end crosses the signal post, so when the rear end crosses the signal post, at that instant, the velocity will become v. So we have to find the velocity with which the middle point of the train passes the signal post. Something like this. When the middle passes the signal post, we have to find this velocity. Let us call this as v prime. So I'm calling these 3 instants. Let us say the first instant is t1, and the second instant when the middle crosses the signal post is t2, and when the rear crosses the signal post, that instant is t3. So let us apply equation of motion between t1 and t2, right? And then we can apply between t2 and t3, and we'll try to simplify the equations. So let us see. So if we apply between, say, t1, let us apply between t1 and t3, right? So we can use this relation. So v square is equals to u square plus 2as. Now here displacement is nothing but the length of the train. So let me take the length of the train as L. Now if we apply the same equation of motion between t2 and t3, in that case the displacement of the train is L by 2. So we can say it will be v square is equals to v prime square plus 2a L by 2. Right? Now what we have to do, we have to eliminate AL. Okay, so what we're going to do, let us multiply this equation with 2, and now we can subtract. So let us subtract these 2 equations. So we'll get minus v square is equals to u square minus 2v prime square plus 0. So v prime square is equals to u square plus v square by 2. So v prime is root of this, right? U square plus v square by 2. So option 1 is the right answer. Now that is the next problem type, which is based on the displacement in nth second, and here we're going to use this formula. As nth will be u plus a by 2 2n minus 1. Again, this formula is applicable if we have a uniform accelerated motion, right? A body travels 102.5 meters in nth second and 115 meters in n plus 2th second. The acceleration is, let us apply this formula 2 times. So 102.5 is equals to u plus a by 2, and that will be 2 times n minus 1, and 115 is equals to u plus a by 2 to n plus 2 minus 1, right? And we have to find the acceleration. Okay, so one thing we can do, let me simplify this further. So it will be u plus a by 2 times 2n minus 1 plus 4, or this can be written as u plus a by 2 2n minus 1 plus 2a. Now if you look at these first two terms, it is nothing but u plus a by 2 times 2n minus 1, which is 102.5. So 115 minus 102.5 will give us 2 times a, right? So this comes out to be 12.5 by 2. So the acceleration comes out to be 6.25 meter per second square. So option 1 is the right answer. Now let us see this question. The displacement and the increase in the velocity of the moving particle in the time interval t to t plus 1 second are 125 meters and 50 meters per second. Now t to t plus 1 is the this 125 meters is the displacement in t plus 1th second. So s t plus 1th is given to us. So we can write this as, right, so it will be u plus a by 2 times 2 times t plus 1 minus 1, right? And we have to find the distance traveled by the particle in t plus 2th second. And increase in velocity is also given. It is from t to t plus 1. So in 1 second, the velocity has increased by 50 meters per second. So we can say acceleration is dv by dt. So that will be 50 divided by 1 second. So that will be 50 meters per second square. So we got the acceleration. And this is given as 125 meters. U plus a by 2 is 25. Then it will be 2t plus 1 minus 1. And we have to find the displacement in t plus 2th second, which will be u plus 25 2 times t plus 2 minus 1, or I can write this as u plus 25 to t plus 1 plus 2 minus 1, or I can write this as u plus 25 to t plus 1 minus 1 times 50 plus 50, sorry. Now these first two term is nothing but 125. So 125 plus 50 will be the displacement in t plus 2th second. So 175 meter is the answer of this question. Now let us see the next problem based on the same problem type. A body moves on a frictionless plane starting from rest. So initial velocity is given as 0. And Sn is the distance moved between n minus 1 to n, which is nothing but the displacement in nth second. And Sn minus 1 is the distance moved between n minus 2 to n minus 1, which is the displacement in n minus 1th second. We have to find the ratio of these two displacements, Sn minus 1 upon Sn, which is given as 1 minus 2 by x for n equals to 10. So Sn minus 1 upon Sn. So here I am going to use Snth formula, which is u plus a by 2 2n minus 1, and u is 0, so it will be nothing but a by 2 times 2n minus 1. So it can be written as a by 2 2n minus 1 divided by a by 2 2n minus 1. So a by 2 will get cancelled out. So this will be 2n minus 3 divided by 2n minus 1, and n is given as 10. So that will be 17 divided by 19. And it is given as 1 minus 2 by x, and we have to find the value of x. So 17 by 19 minus 1 is equals to minus 2 by x, which is minus 2 by 19 is equals to minus 2 by x. So x is nothing but 19. So 19 is the answer. Now let us see the next problem type, which is based on the stopping time and the stopping distance. A bus moving along the straight highway having a speed of 72 kilometers per hour is brought to halt within 4 seconds. So this 4 seconds is the stopping time, right? So that is the stopping time. After applying the brakes, the distance traveled by the bus during this time. So we have to find the stopping distance. So stopping time, I told you it is v by a, that will be the stopping time. So from this we can find acceleration, which is v by t, and v is 72 kilometers per hour, can be written as in meters per second as 72 times 5 by 18. So that will give us 4, so it will be 20 meters per second. So 20 divided by 4, so that will give us 5 meters per second square. So that is the acceleration or the retardation. Now we have to find the stopping distance. Stopping distance is v square by 2a. V is 20 and a is 5. So that will be 400 divided by 10, which is 40 meters. Right, so 40 is the answer of this question. Now let us see the next problem. Given below are two statements. Statement 1, a truck and a car moving with the same kinetic energy are brought to rest by applying brakes, which provide equal retarding force. So it means we have a truck and a car, right? Retarding force is same, and force is mass times the acceleration. And we know that the truck mass is, like, truck is much more heavier as compared to car. So acceleration of the truck will be, since mass is more, acceleration of the truck will be less than retardation of the car. Both comes to rest in equal distance. So what is equal to, so what is the, and they have the same kinetic energy. So kinetic energy of truck is same as kinetic energy of the car. So it is half mass of the truck times velocity of the truck square. That will be half mass of the car times velocity of the car square. So we can say Vt square by Vc square is equals to mc by mt, and we have to find the we have to check whether they have the same stopping distance or not. And we know that stopping distance is given as v square by 2a, right? And so we can say for truck this will be Vt square divided by 2at, and for the car it will be Vc square divided by 2ac, and ac is nothing but f by mc, right? So that can be written as Vc square divided by 2f by mc. Similarly here, this can be written as Vt square divided by 2f divided by mt. So can you see this, in the numerator we are getting mv square, right, which is nothing but the kinetic energy. So if the kinetic energy, initial kinetic energy is same and the retarding force is same, we can say both will have the same stopping distance, right? So statement 1 is correct. Statement 2, a car moving towards east takes a turn and moves towards north. So a car which is going in the east direction, it takes a turn, starts moving in the north direction, and the speed remains unchanged. The acceleration of car is 0. Since the direction of the velocity has changed, there will be acceleration. So statement 2 is incorrect. So statement 1 is correct, statement 2 is incorrect, option 1 is the right answer. Now let us see this question. A car is moving with a speed of 150 kilometers per hour, and after applying the brake, it will move 27 meters before it stops. If the same car is moving with the speed 1/3 of the reported speed, then it will stop after traveling what distance? We know that stopping distance is directly proportional to square of the velocity and inversely proportional to the acceleration or the retardation. And since we have the same car, we are applying this, we are exerting the same amount of force. So we are assuming acceleration is same. So we can say the stopping distance will be directly proportional to square of the velocity. Since we have decreased the velocity by a factor of 3, the stopping distance will decrease by the factor of 9. So the stopping distance now will become 27 by 9, which will be 3 meters. So 3 is the answer of this question. For a train engine moving with a speed of 20 meters per second, the driver must apply brakes at a distance 500 meters before the station for the train to come to rest at the station. So basically this is the stopping distance, and from this we can find the retardation which is being produced by the engine. If the brakes were applied at half of this distance, the train engine would cross the station with a speed root x. The value of x, Obviously, now the stopping distance will increase. So first, let us find the retardation by the first statement. So so we know that stopping distance will be v square by 2a. So a will be v square by 2s. So v is given as 20 and stopping distance is given as 500. So that will be 400 divided by 1000, which is 0.4 meter per second square. Now we got the retardation. So if okay, right. So if the brakes were applied at half of this distance, now let us say this is the station and this is the train, and this distance is 250. We know the retardation. So we have to find the velocity, right? So here the velocity of the train is 20 meters per second. Let us say here the velocity becomes v. Now we can apply second equation of motion, the third equation of motion. So v square is equals to 20 square minus 2as, which is 250. And we can find the velocity of the train at the station. So it will be 400 minus, so that will be 0.8 times 25. So 8 times 25 will be 200. So this comes out to be 200 and v square is 200. So v is root 200 and this is given as root of x. So x is nothing but 200, right? So 200 is the answer. A train, now this question is based on another problem type, which is average speed calculation. A train starting from rest first accelerates uniformly up to the speed 80 kilometers per hour for time t. Then it moves with the constant speed for time 3t. The average speed of the train for this duration of journey will be. Okay, right. So let me first draw velocity time graph so that you have the idea what they're talking about. So on the y-axis we have velocity, on the x-axis we have time. And when we have uniform acceleration, velocity time graph is a straight line. And in this case, the particle is starting from rest. It will be a straight line passing through the origin. So that is the, so after time t, it will acquire maximum velocity. Let me call, and this velocity is 80. So this velocity is 80 kilometer per hour. And after that, it moves with the same velocity for 3t time. When the velocity is constant, then it will be, the graph will be parallel to the time axis. And here we have 4t. Now we have to find the average speed. So first let us find the total. So for average speed, we should know what is the total distance, and then we have to divide that with the total duration. So if we have given velocity time graph, we can find the displacement. So the area under this graph will give us the displacement, and it's a trapezium, and the area of a trapezium is half times sum of the parallel sides and the distance between parallel side. Now the distance between parallel side is 80 kilometers per hour, and the parallel sides are 3t and 4t. So it will be half sum of parallel sides, so 3t plus 4t times distance between parallel side, which is 80 kilometer per hour, and divided by the this is the total displacement divided by the duration, which is nothing but 4t. So this will be 7 by 8 times 80 kilometers per hour. So this will be in kilometer. Let me convert kilometers per hour into meters per second times 5 by 18. So this will give us 9, and this will be 40. This will give us 5. And okay, we have to find the average speed in kilometers per hour. Okay, right. So no need to convert this into meters per second. We can directly get the answer. So it will be 40. So it will be 7 by 8 times 80. So it comes out to be 70 kilometers per hour. So option 4 is the right answer. Now the next problem type is based on vertical projection from the ground. So here we are projecting a ball from the ground. A ball is thrown vertically upward with the initial velocity of 150 meters per second. So this velocity is 150 meters per second. The ratio of the velocity after 3 seconds and 5 seconds is x plus 1 by x. The value of x is. So in this question, let us assume upward direction is positive or downward direction is negative, right? And downward is negative. So initial velocity will be plus 150 meters per second. And the acceleration, since the ball is moving in gravity, so acceleration will be minus 10 meters per second square because it is acting in the downward direction. And we have assumed downward direction is negative. Now velocity is given as u plus 80. And it will be 150 minus 10 times t. So velocity at 3 seconds will be 150 minus 10 times 3, that will be 120 meters per second. And velocity at 5 seconds will be 150 minus 10 times 5, which is 100 meters per second. And this, so the ratio of these two, so 120 upon 100 is given as x plus 1 by x. And this is nothing but 6 by 5, or 5 plus 1 by 5 is equals to x plus 1 by x. So x is 5. So option 2 is the right answer. Now let us do the next question. An object is thrown vertically upwards. At its maximum height, which of the following quantities becomes 0? So at the maximum height, velocity is 0. Acceleration is non-zero. Momentum, if velocity is 0, momentum is also 0. And okay, right, so which of the following quantity becomes 0? So momentum will become 0. Potential energy, so if we assume potential energy of the ball when it is on the earth's surface is 0, then it will have increased potential energy. And acceleration is non-zero, so B can't be the answer. There will be a gravitational force. It is so D option is also incorrect. So option A is the right answer. Now let us see this illustration. It is a typical juggler problem. So let us see. A juggler throws ball vertically upward with the same initial velocity in air. When the first ball reaches the highest point, he throws the next ball, assuming the juggler throws n balls. So we have given frequency, right? So n balls being thrown in 1 second. The maximum height of the balls can reach. Okay, right. So let us see what we can do. So and it throws the next when the first one reaches the top, right? So first let us find the time taken by the ball to reach the topmost position. So here let's say the initial velocity is u. So if we apply first equation of motion, so v is equals to u plus at. So v is 0, u is u, and that is minus g. So we got the time, that will be u by g. So in u by g time, we are throwing the balls, right? And we know that, so one ball is being thrown in u by g seconds, and for throwing n balls, it will be ug times n seconds, right? And we know that we are throwing n balls, the juggler is throwing n balls in 1 second. So 1 is equals to u by g times n, or we can say u is g by n. Now we got the initial velocity with which we are throwing the ball, and we have to find the maximum height attained by the ball. So if you're throwing a ball with g by n, the maximum height will be v square is equals to u square plus 2as. So v is 0, u is g square by n square minus 2g, and the h maximum height. So h max will be, it will be g square by 2n square g, which is nothing but g by 2n square. So option D is the right answer.
Now let us see this question. A ball is thrown with a certain velocity so that it reaches a height h. Find the ratio of the two different times of the ball reaching h by 3 in both the direction. Okay, right. So first let us understand the question. So we are throwing a ball from the ground, and let us say the initial velocity is u, and the maximum height attained by the ball is h. So that is given, and the ratio of two different times. So basically, if I consider a height which is h by 3, the ball will cross this height h by 3 2 times. So let us say this point is O and this point is A, and while coming back again at point A, right? So let me show you two paths. So this is the first one. In the second case, it goes up and then returns. Okay, and again it is reaching the same point A at the same height. Let us say the time taken by the ball from O to A directly is T1, and time taken by the ball to reach A again will be T2. So we have to find T1 by T2. Okay, so that's what we have to calculate. So how we can do that? So let us apply second equation of motion, S equals to ut plus half at square. Now what we're going to do, we'll substitute S as h by 3 and u is the initial velocity, and we have given the maximum height, so we can find initial velocity in terms of h. So let us calculate that. So u is the initial velocity and the maximum height is h. So if we apply v square equals to u square plus 2as, so v will be 0. It is u square minus 2gh. So we got u as root 2gh, right? Okay, even you can, we know this result also. So u is root of 2gh t plus half, and a will be minus g t square. Now we got a quadratic in t, and it will be having two roots. So we can say t1 and t2 are the two roots, right? Because it tells us what is the displacement of the ball from the initial position, and that will be h by 3 only. So now let us simplify this further. So I can write this as g by 2t square equals to minus root of 2gh times t plus h by 3. So we got this quadratic. So what is the sum of roots? So t1 plus t2 will be minus b by a. Okay, so we got this, and this can be written as root 8 h by g, right? And if you want to find the product of roots, so t1 t2, that will be c by a, so that will be h by 3 divided by g by 2. So it will be 2 by 3 h by g, right? Now we got t1 plus t2. Let us find t1 minus t2. So t1 minus t2 will square of that is t1 plus t2 square minus 4 times t1 t2, right? Okay, now let us substitute the value of t1 plus t2 and t1 t2 in this equation. So t1 minus t2 square will be equals to, it will be root of 8 h by g square minus 4 times 2h by 3g. So this can be written as 8h by g minus 8h by 3g. So this comes out to be, so 8h by g will be common. So we have 1 minus 1 by 3, which is 2 by 3. So 2 by 3, 8h by g. So it comes out to be 16 by 3 h by g. So we got the, so t1 minus t2 will be root of 16 by 3 h by g, right? Now since t1 minus t2 is positive, so what we can say, this t1 corresponds to this t2, right? And this t2 corresponds to t1, and we have to find the ratio. Okay, let me write it as t1 and this as t2, right? So we have to find t2 by t1. Okay, right. Now let us use the equation 1 and the equation 2 to find t1 and t2. So if we add 1 and 2, okay, we have to find t1 and t2, right? So it will be t1 plus t2 divided by t1 minus t2, and this comes out to be root h by g will get cancelled out. t1 plus t2 is, that will be root 8 divided by root 16 by 3, or we can write this as root of 8 divided by 16 times 3, so that will be 2. So it is root 3 by 2. So t1 plus t2 upon t1 minus t2 will be root 3 by root 2. And if we use componendo dividendo, we will get t1 by t2 as root 3 minus plus root 2 divided by root 3 minus root 2. And if you look at the options, all the options are less than 1. Basically, they have found the ratio of t2 with t1, right? So t2 by t1 is root 3 minus root 2 upon root 3 plus root 2. So option 3 is the right answer. Now let us see the next question. A body projected vertically upward with a certain speed from the top of a tower reaches the ground in t1. So we have given a tower and a ball is projected vertically upward. So we are projecting a ball in the upward direction. Let us say the velocity is u. And it attains a maximum and then comes down and then hits the floor, right, at this particular point, and the time taken is t1. If it is projected vertically downward from the same point with the same speed. So if we are throwing this ball in the downward direction with the same speed, it will take t2 time. Now time required to reach the ground if it is dropped from the top of the tower. So if we are dropping this ball with the initial velocity 0, what is the time taken? So that's what we have to calculate. Let us say this is t3. So what we can do in this case, since time t1 is given, initial velocity is given, right? And let us assume that the height of the tower is h. So let us apply second equation of motion 3 times. So first let us apply for the first case, then for the second case, and then for the third case, and then we'll try to manipulate the equations. So if we apply the equation for the first case, if we consider downward as positive, then the initial velocity will be negative. So it will be h equals to minus u t1 plus half g t1 square. And for the second case, it will be h equals to plus u t2 plus half g t2 square. Now for the third case, h is equals to half g t3 square because u is 0. Now what we can do, let us eliminate u, right, in these in first two equations. How we can do that? Let us multiply the first equation with t2 and the second equation with t1, and then we can add these two equations. So when we add, we will get h times t1 plus t2 plus half g, so not equal, it should be equals to plus half g t1 t2 times t1 plus t2. So can you see we will be able to eliminate t1 plus t2. So this can be eliminated and we'll get h is equals to half g t1 t2, right? Now what you have to do, you have to compare this equation with this equation. So if we compare that, then t1 t2 comes out to be equals to t3 square. So t3 is nothing but the geometrical mean of t1 and t2. So option 1 is the right answer. Even you can remember this result also. Now let us see the one more illustration based on the same problem type. So we have given a ball is thrown vertically upward with a velocity 19.6 meters per second from the top of a tower. The ball strikes the ground after 6 seconds. So we have given time of flight and the height from the ground up to which the ball can rise will be. So we have to find the maximum height attained by the ball from the ground. Now let me first draw the diagram here. So this is the tower, and from this tower we are throwing a ball in the upward direction. So it goes up, attains maximum height and then comes down. And the time of flight is 6 and the height of the tower is not given to us. So let us assume that the height of the tower is h. And initial speed of projection is also given, that is 19.6. So that is 19.6 meters per second. Now I'm going to apply, time is given, right? So I'm going to apply second equation of motion. So S is equals to ut plus half at square. So by using this equation, we'll be able to find the height of the tower. So I'm assuming downward direction is positive. So h is equals to minus 19.6. T is given as 6 plus half g is 9.8 times t square, which will be 36. So this will give us 18. Now from this 9.8 will be common. So we'll be having minus 12 plus 18. So that will be 6 times 9.8. So we got height, and now we have to find the height from the ground. So what is the maximum height attained? So again I can apply second equation of, or you can say we can apply the third equation to find the height attained by the ball, maximum height attained by the ball from the top of the tower. Let me call this as small h. So we can apply v square is equals to u square plus 2as, and v is 0 at the highest position, u is 19.6, and I have taken upward as positive in this case, so downward will be negative. So 2 times minus 9.8 times h, and so this comes out to be 19.6 times 19.6 divided by 19.6. That will be h. So it comes out to be 19.6, or you can say it will be 2 times g. So we got small h, we got a capital H. So the maximum height attained by the ball from the ground will be h plus small h, which is 6g plus 2g, which is 8g, and it will be 8 times 9.8. Okay, and this value is given as k by 5. So this comes out to be what? So it will be 8 times 49, that will be k, and it will be 392. So k comes out to be 392. So 392 is the answer of this question. Now let us see the next problem type, where we are dropping a ball from the height. A ball falling under gravity covers 2 points A and B separated by 80 meters in 2 seconds. The distance of the upper point A from the starting point. Let me just draw the diagram here. So we are dropping a ball from certain height, and the initial velocity is 0. And I'm assuming 2 points A and B, and the distance between A and B is 80. So this distance is 80 meters. And the ball covered like AB distance in 2 seconds. So that is given to us. And we know that we are dropping it from rest. So what I'm going to do, let me call the initial position as O. Now let us apply equations of motion between OA and OB. Why I'm taking O? Why I'm taking the initial instant? Because the initial velocity is 0. It makes our calculation easier. So let us say the ball take t time to reach A, and it will take t plus 2 seconds to reach B, because it is clearly given that in 2 seconds it has a displacement of 80 meters from A to B. Now if I apply equation of motion from O to A, it will be S is equals to ut plus half at square, or I can write S as O times OA, and u is 0, half g, and it will be t square. If I apply the same equation of motion from O to B, it will be OB plus equals to 0 plus half g t plus 2 square, right? And the difference of OB and OA is given as 2 meters. So if I take the difference of these two, we'll get 2 meters, half g t plus 2 square minus t square. Now this equation will give us the value of t. Once we know the value of t, we can find the distance of A from O. That's what we have to calculate. So it will be 4 by 10. And this can be written as t square plus 4t plus 4 minus t square. So t square will get cancelled out. So it will be t plus 1 times 4 is equals to 4 by 10. So 4 we can eliminate. And from this T comes out to be, so this will be 2, sorry, the distance between them is 80, not, okay, let me rewrite this. It is 80. Okay, so it will be 160 by 10, and this will be t square plus 4t plus 4 minus t square. So t square will get cancelled out. So we can take 4 common in the right hand side. So t plus 1 is equals to 40 by 10, which is nothing but 4. So t comes out to be 3 seconds. Now we got the time taken by the ball from O to A. Now we can find the distance of A from O by substituting t in this equation. So OA is half g t square, 9. So this will be 45 meters. So 45 is the answer of this question. Now let us see the next problem based on the same problem type. A ball of mass 0.5 kg is dropped from the height of 10 meters. The height at which the magnitude of the velocity becomes equal to the magnitude of the acceleration. Let me show you here. So we have given certain height. Let us say we are dropping a ball from a tower. This is the ground, and the ball, the mass is given as 0.5 kilograms, and we have to find the height of the point where the velocity magnitude will become equals to acceleration. And we know that acceleration is 10, so velocity should become 10, right? So let us say at a depth h, the velocity becomes 10. At this point, the velocity is 10 meters per second. So if I apply, and we have to find the value of, this is 10, right? So height of the tower is 10. And we have to find 10 minus h, right? We have to find the height where the velocity becomes equals to acceleration in terms of magnitude. So let us first find h. So we can say, we can apply second equation of motion as, okay, right? So, velocity is given, right? So let us apply third equation of motion. So v square is equals to u square plus 2as. So v becomes 10, initial velocity is 0, and acceleration is 10, and we can find h. So it will be 100 divided by 20, so that will be 5 meters. So h comes out to be 5 meters. So the height of the point where velocity magnitude becomes equals to acceleration magnitude is 10 minus h, which is again 5 meters. So 5 is the answer of this question. Now let us see another problem based on the same problem type. When a ball is dropped into a lake from a height of 4.9 meters above the water level, it hits the water with a velocity v and then sinks to the bottom with a constant velocity v. So it means as soon as it hits the water, it acquires terminal velocity and keeps on moving with the same velocity. It reaches the bottom of the lake 4 seconds after it is dropped. 4 seconds after it is dropped, right? Right. So the approximate depth of the lake. Let us see. So we are dropping a ball, and let us, this is the free surface of water, and the depth of the lake, this is the river bed or lake bed, and this depth is, say, capital H, and we have to find capital H. Let me call this point as O, this point as A, this point as B, and the time from O to B is given as 4 seconds. So time from O to B is 4 seconds. And water level height, depth of water level from the point where we are dropping the ball is 4.9 meters. So that is given. So we can find the velocity just before hitting the water surface, and that velocity will be root of 2gh. So 2 times g, let us take g as 9.8 and h is 4.9. Okay, right? So if I do it like this, it will become 2 square times 4.9 square, right? Root of that. So that will be 2 times 4.9. So we can say the velocity just before hitting the water surface is 9.8 meter per second. And it keeps on moving with the same velocity in water. So that will be 9.8. So the time from O to A, let us find the time from O to A. So time from O to A will be root of 2h by g. 2 times 4.9 by 9.8. g. So this comes out to be 1 second. So it means the time taken by the ball from A to B will be how much? Total time is 4 seconds, right? So time from A to B will be 4 minus 1, which will be 3 seconds. And we know, now we know the time from A to B, and it is moving with a constant velocity of 9.8 meters per second. So AB distance will be, or h will be, speed into time. Speed is 9.8 and the time is 3 seconds. So it comes out to be 29.4 meters. So option B is the right answer. Now let us see another problem based on the same problem type. NCC parade is going at a uniform speed of 9 kilometers per hour under a mango tree on which a monkey is sitting at a height of 19.6 meters. At any particular instant, the monkey drops a mango. A cadet will receive the mango whose distance from the tree at the time of drop is. Okay, right. So let us see what we have given. So there is a monkey and he's dropping mangoes. Okay, so he's dropping mango and the height is given as 19.6 meters. So here I'm ignoring the height of the cadet. So let us say this particular cadet receives the mango right on him. So it means when the monkey drops the mango, the time taken by the mango to reach bottom is same as the time taken by the cadet to reach the location of the mango, right? So let me call this point as O, this point as A, this point as B. So the time taken by the mango from B to A is same as the time taken by the cadet from O to A, and cadet is moving with a constant velocity which is given as 9 kilometers per hour. So 9 times 5 by 18. So this comes out to be 2.5 meters per second. So the cadet, so cadet is moving with 2.5 meters per second, and the time taken by the mango to reach A will be root of 2h by g. So 2 times h is 19.6, g is 9.8. So this will be 2, it will be 2 seconds. So in 2 seconds, the cadet will reach A. So, and we have to find OA, right? So distance is speed into time, and speed is 2.5, time is 2. So that will be 5 meters. So option A is the right answer. Right, so let us see another problem based on the same problem type. A ball is released from the height h. If t1 and t2 be the time required to complete first half and the second half of the distance respectively, right, then choose the correct relation between t1 and t2. So here we have dropped a ball with initial velocity 0 and this height is h, and let me take the midpoint of this height h as A, and the point just before hitting the ground is B, and this, let me take the initial position as O, and we have to find the ratio, or we have to find the relation between time from O to A and time from A to B, and time from O to A is t1 and time from A to B is t2. So what we're going to do, we'll apply equation of motion from O to A, and then we'll apply equation of motion from O to B, and we'll try to find the relation between the time. So I'm going to use like second equation of motion, s is equals to ut plus half at square. So if you apply from O to A, it will be h by 2 equals to initial velocity is 0 plus half g t1 square. Now if you apply the same equation of motion from O to B, here the height will be h 0 plus half g, and the total time will be t1 plus t2, right? Now from this we can take the ratio, right? So let us take the or if I just multiply the first equation with 2, we can equate these two equations. So we can say g t1 square is equals to g by 2 t1 plus t2 square. Now from this g will get cancelled out. So we got 2 equals to t1 plus t2 square divided by t1 square. Now from this we can also write this as 1 plus t2 by t1 square, and let us take the square root on both sides. So this will become root 2 minus 1 is equals to t2 by t1, right? So t2 will be root 2 minus 1 times t1. So t2 is root 2 minus 1 times t1. So option D is the right answer. Right, so now let us see another problem based on the same problem type. So water droplets are coming from an open tap or at a particular rate, and the spacing between a droplet observed at 4th second after its fall to the next droplet is 34.3 meters. At what rate the droplets are coming from the tap? So let us say they are coming after x seconds, right? Let us say after x second is the time interval between the drops, and we have given after 4 seconds. Let's say this is the droplet which is coming out from the tap, and this is the location of the tap, right? And so this will be t equals to 4 seconds, and the next drop is this one, right? And so this is 4 after 4 seconds, so this will be 4 minus 4 minus x, right? 4 minus x seconds. So what we can do, and what we have given that the distance between these two drop is 34.3, right? So, and the initial velocity was 0. Let me call this point as O, this point as A, this point as B. Now I'm going to apply equation of motion from O to A and then from O to B. So we can say OB is equals to half g t square, and t is 4 seconds, and OA is half g 4 minus x square, and this x we have to calculate, and the difference of OB and OA is 34.3. So if you take the difference of these two, so it will be 34.3 is equals to half g 4 square minus 4 minus x square, and so this will be 34.3 divided by 9.8 times 2. So it will be 16 minus, okay, let me apply a square minus b square formula. So this will become 4 plus 4 minus x times 4 minus 4 plus x. So this will be 8 minus x times x, so which is 8x minus x square, and this will be how much? So we have 9.8. So this will be how? This will be 3.5, right? So this is 7. So x square minus 8x plus 7 is equals to 0. Let us apply splitting the middle term. So it will be minus 7x minus x plus 7. So from this x comes out to be 7 or 1. X can't be 7, right? Otherwise this 4 minus x will be negative. So x has to be 1. Okay, so it means one drop is getting one drop is being released after 1 second. So option 3 is the answer. Now let's see this question. A stone is dropped from the top of a building. When it crosses a point 5 meters below the top, another stone starts to fall from the point 25 meters below the top. Both stones reach the bottom of the building simultaneously. The height of the building is, okay, let us see. So this is the building, and we are releasing, let us, this is the first stone, and when it passes this particular point B, let me call this point as C, right? 5 meters below the topmost point. So this is 5 meters. another stone starts to fall from the point 25 meters below the top. Okay, right, so let us take this particular point. This is the second stone, right? And its initial velocity is 0. Its initial velocity was 0. And both the stone reaches the bottom simultaneously. So let us first find the velocity of the stone when it has a displacement of 5 meters. So this velocity, let me call this velocity as v. So v square is equals to u square plus 2as can be applied. So v square is equals to 0 plus 2 times a, I'm taking g as 10, and this is h, right? So this comes out to be how much? It will be 100. So v comes out to be 10. So v is 10. So let me call this instant as t equals to 0, and at t equals to 0 the second stone is at a depth of 25 meter from the top, right? And let us take this distance as h. So this distance will be 25 minus 5. So, and they reaches the bottom simultaneously. So the time taken by the first stone to reach bottom is same as the time taken by the second stone to reach bottom. So again we're going to apply S is equals to ut plus half at square formula. So for first stone, the displacement is 20 plus h is equals to half ut. U is 10 and t plus half g t square. Now if you apply the same equation for the second stone, it will be h is equals to initial velocity is 0, so half a t square. Now what we're going to do, we can we can just subtract these two equations. So we will get 20 is equals to 10t. So t comes out to be 2 seconds. So we got t, and we have to find the height h, height of the building. So let us first find h. So h is half into 10 times 2 square, so that will be 20 meters. So b is released at a height of 20 meter from the ground. So 20 plus 25, so 45 is the answer, right? 20 plus 25. So option 2 is the right answer. Now let us see the next problem type, which is based on the air resistance in the vertical projection. An object of mass 5 kilograms is thrown vertically upward from the ground. So we are throwing a stone in a vertically upward direction, and its mass is 5 kg. The air resistance produces a constant retarding force of 10 Newton throughout the motion. And you should also remember, like whenever there is a air resistance, it is always the force exerted by air is always opposite to the velocity. So when the stone or the object is ascending, then the force will be in the downward direction, and when it is descending, the air resistance force will be in the upward direction. So what we're going to do, when the stone is ascending, let us find the acceleration reduced, net acceleration reduced, right? So if it is ascending, when it is going up, if I draw the free body diagram, there will be a gravitational force which will be 50 Newton, and there will be an air resistance which is also in the downward direction, which is 10 Newton. So we can say there will be a retardation. Let me call this as A1. It will be 60 divided by the mass of the body, which is, so it will be 12 meters per second square. And when the stone is coming down, again let us draw the free body diagram. So there is a gravitational force acting in the downward direction, which will be 50 Newton, and there will be a air resistance in the upward direction, which will be 10 Newton. So acceleration while it is descending is 50 minus 10 divided by the mass, which is 5. So it will be 40 by 5, which is 8 meters per second square. Now we have to find the ratio of the time of ascent to the time of descent. So time of ascent is nothing but root of 2h, let us say capital H is the maximum height, by a1, and the time of descent is root of 2h by a2. So the ratio of these two will be 1 upon root a1 ratio 1 upon root a2, or you can say root a2 ratio root a1, which is root of 8 ratio root of 12. and this can be written as 2, this can be written as 3, so it will be root 2 ratio root 3. So option B is the right answer. Now let us see the next problem type, which is based on the penetration of bullet in a block. A bullet of mass 0.1 kilogram is fired on a wooden block to pierce through it, but it stops after moving a distance of 50 centimeter into it. So we have given a wooden block and we have fired a bullet, and this bullet stops after having a displacement of 50 centimeter inside the block. So this displacement is 50 centimeter. Mass of the bullet is given as 0.1 kilograms. If the velocity of the bullet before hitting the wood is 10 meters per second, so this velocity is given as 10 meters per second, and it slows down with a uniform deceleration, then the magnitude of the effective retarding force on the bullet is x Newton. The value of x will be, so we have to find the retardation. Once we know retardation, we can multiply it with the mass, we'll get the retarding force. So here velocity, this is u and v is 0. Now we can apply third equation of motion. So v square is equals to u square plus 2as, so that will be 0. It will be 10 square plus 2 times, let me take it as minus a, and s will be 0.5 meters. So acceleration comes out to be, retardation comes out to be 100. So the force will be 100 times the mass, so it comes out to be 10, right? So the answer will be 10. Now let us see another problem based on the same problem type. A bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 centimeters. So we have given a fixed target. Let us say this is the fixed target, and there is a bullet, and it loses 1/3 of its velocity. Suppose if it is having velocity u, after penetrating 4 centimeter, its velocity becomes, it loses 1/3, it means u minus u by 3, which is 2u by 3. It penetrates further d into 10 raised to power minus 3 meters before coming to rest. Let us say the bullet has traveled additional distance of d into 10 raised to power minus 3 when it and then it comes to rest. So final velocity is 0. And we have in such questions we should always assume uniform retardation. So let us take the initial instant as O, this is A and this is B. Now I'm going to apply third equation of motion from between O to A and then from A to B. So from O to A I can say 2u by 3 square minus u square is equals to 2a with a negative sign s, and s in this case will be 4 centimeter. Now we can apply the same equation from A to B. So that will be final velocity, that will be 0 minus initial, that will be 2u by 3 square, and this will be equals to minus 2a times d into 10 raised to power minus 3. So this is in meters, so let me convert this 4 centimeter into meters. Now let us take the ratio of these two. So it will be 4 by 9 minus 1 divided by 4 by 9. So u square will get eliminated, and 2a will get eliminated, minus 2a, so that will get 4 into 10 raised to power minus 2 divided by d into 10 raised to power minus 3. So this will give us 10 in the numerator. So it will be 4 minus, yeah, there is a negative here. So 4 minus 9 by 9 divided by minus 4 by 9. So 9 will get cancelled out. So 40 by d. So it will be minus 5 upon minus 4 equals to 40 by d. So this will give us 8. So d comes out to be 32. So option 4 is the right answer. Now let us see the next problem type, where the particle first accelerates and then decelerates to come to rest. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. If the total time elapsed is t seconds, the total distance traveled is, so we have to find the total distance. So let me first draw the velocity time graph in such questions. So v on the y-axis and t is on the x-axis. So first it accelerates with a constant rate alpha, so it will be a straight line, so that is alpha, and then it decelerates with a constant rate beta. Again it will be a straight line, but the slope will be negative, and it comes to rest. So let us say if I take these point O to A, so while when the car is accelerating, let us say it has accelerated for t1 interval, so this time is t1, and it decelerates for t2 interval, right? Now if I apply equation of motion from O to A, we can say velocity at A, which is nothing but the maximum velocity attained by the vehicle. So let me take it as Vm. So Vm is equals to U plus At, that will be alpha T1. Similarly, we can apply the same equation from A to say B, and that will be Vm is equals to beta T2. Now from these two equations, we can find T1 and T2. So T1 is equals to V1 by alpha, T2 will be Vm by beta, and we know the total time of journey, so that will be T1 plus T2, which is T, and it will be Vm times 1 by alpha plus 1 by beta. And we know that the displacement is nothing but the area under velocity time graph, so it will be half, and the base is nothing but total time, and the height is Vm. Now from this we can say Vm is equals to alpha beta T divided by alpha plus beta. Now I'm going to substitute Vm value in this equation, so S comes out to be half T square alpha beta upon alpha plus beta. So option 3 is the right answer. Now let us see another question based on the same problem type. A scooter accelerates from rest for time t1 at a constant rate a1, and then retards at a constant rate a2 for time t2 and come to rest. The correct value of t1 by t2 will be, so we again let me draw the diagram graph. So on the y-axis we have v, on the x-axis we have time. First it accelerates with a constant rate a1 and then decelerate with a constant rate a2, and this duration is t1 and this duration is t2. Okay, so we can say the maximum velocity attained is Vm. So Vm is equals to a1 times t1, Vm is equals to a2 times t2. So t1 by t2 will be a2 by a1 if I take the ratio. So it should be a2 by a1, so option 2 is the right answer. Now let us see the next block where I'm going to study non-uniform accelerated motion in 1D. Let us see the question based on that. The relation between time t and the distance x is t equals to alpha x square plus beta x, where alpha and beta are constants. So this equation is given. The relation between acceleration and velocity is, so we have given t as alpha x square plus beta x, and we have to find the relation between acceleration and velocity. So whenever we have such kind of a question, the first thing is let us differentiate this, because we have x, so if we take the first derivative of x, we'll get velocity, and the second will give us acceleration. So let me first take the first derivative. So it will be 1, and it will be 2 alpha x times v plus beta times v, right? Now from this we can say v is nothing but 1 upon 2 alpha x plus beta, right? So now let us again differentiate these equations, because we want to find the acceleration also, right? So if we differentiate this, left hand side will become 0. Now we can apply product rule, because we have x times v. So it will be 2 alpha times the differentiation of x will be v. So it will be v square, and the differentiation of v will be acceleration. So it will be x times a, and then beta times a, right? Now from this we can take a, let us take the let us club all the terms which is containing a. So it will be 2 alpha v square plus a times 2 alpha x plus beta is equals to 0. And if you look at this relation, v is equals to 1 upon 2 alpha x plus beta. So 2 alpha x plus beta is 1 by v. So it will be minus 2 alpha v square is equals to a by v. So a will be minus 2 alpha v cube, right? So option 1 is the right answer. Now let us see this question. A particle moves in a straight line so that its displacement x at any time t is given by this equation, x square is equals to 1 plus t square. Its acceleration at any time t is x raised to power minus n, where n is. So we have to find the acceleration at time t. So let us differentiate this two times. So we have x square is equals to 1 plus t square. So it will be 2x times v is equals to 2t. Right? So from this v comes out to be t by x. Let us differentiate this equation one more time. So it will be v square plus x times a, and that will be equals to 1. So acceleration will be 1 minus v square divided by x. Right? And v is t by x. So we can write this as 1 minus t square by x square divided by x. Right? And we have to find the acceleration at any time t. So what is x square? Let us simplify this. So can you see it is 1 minus, so I can write this as x square minus t square divided by x cube. Now x square minus t square from this equation will give us 1. So that will be 1 by x cube. So that will be x raised to power minus 3. And 3 is nothing but n. So 3 is the answer. Let us see this question. The velocity of the particle is v equals to v naught plus gt plus ft square, where g and f are constants. Its position is x equals to 0 at t equals to 0. Then its displacement after time t. So we have to find the displacement. So let us, so we have v equals to v naught plus gt plus ft square. And we know that dx by dt is velocity. So we can write v as dx by dt. So let me take t on the other side. Dt on the other side. Now let us integrate this. And x is variant. So when t is 0, x is 0. And when t is 1, let us say x, and the displacement is x. So the left hand side will be x minus 0. And we know that integration is distributive over addition. So it will be v naught times t plus gt square by 2 plus ft cube by 3. And the limit will be from 0 to 1. So it will be v naught plus g by 2 plus f by 3. So that is the displacement in 1 second. So the option 2 is the right answer. Now let us the next problem type, which is based on relative motion. A ball is projected vertically upward with an initial velocity of 50 meters per second at t equals to 0. At t equals to 2 seconds, another ball is projected vertically upward with the same velocity. At t equals to, like we have to find the time the second ball will meet the first ball. So we have to find the times from the beginning. Right, so from the ground, we have thrown a ball in the upward direction with a velocity of 50 meters per second. And after 2 seconds, let us say it has reached this particular position. And what should be the velocity? Let us find this v, right? So v, we can apply first equation of motion, v is equal to u plus at for the first ball. So v, u is 50, I'm taking upward as positive and downward as negative. So minus g and times t. And t, time is 2 seconds. 50 minus 10 times 2, so that will be 30 meters per second. So it will be 30 meters per second. And what is the displacement? Let us find the displacement. So this displacement will be, we can apply second equation. S is equals to ut minus half g t square. So it will be 100 minus 20, which is 80 meters. Okay, so displacement is 80 meters. Now we are releasing this, now we are throwing the second ball. So let me show that instant. So we have the first ball. Now we are throwing the second ball with certain velocity. Same velocity, right? So that is 50. and at this instant the velocity of the first ball is 30 and the distance between them is 80. Now we can apply relative motion. So if I observe ball 2 with respect to ball 1, so let us study second ball with respect to first ball. So when we are observing second ball with respect to first ball will be at rest. So initial velocity we can say of second with respect to first, it will be u2 minus u1, and u2 is, and I'm taking upward as positive, so u2 is 50, u1 is 30, so that will be 20 meters per second. Acceleration of 2 with respect to 1 will be a2 minus a1, both have same acceleration g, so that will be 0. So it means with respect to first ball, ball 2 is moving uniformly, it is having a uniform motion, and the distance between them is 80. So it means the second ball is covering, so the distance between them is getting reduced with what speed? 20 meters per second. So we can say the time of meeting will be distance upon speed, so that will be 20, distance will be 80 divided by speed, relative speed is 20, so that will be 4 seconds. And we have thrown second ball after 2 seconds, so the answer will be 4 plus 2, so it should be 6, right? Now let's say this question, train is moving along two parallel tracks towards the north with a speed of 72 kilometers per hour, and train B is moving towards south with 108 kilometers per hour. Velocity of B with respect to A and the velocity of ground with respect to B. So that's what we have to calculate. So let me show you two parallel tracks. So let us, these are two parallel tracks. And this is the train A, which is going towards north, and its speed is 72 kilometers per hour, and we have to find answer in meters per second. Let us first convert this into meters per second. So 72 times 5 by 18, so that will give us 20 meters per second, and this is 108, so 108 times 5 by 18, so that will give us, so it will be 2 1 2, so 6, so 30 meters per second. Okay, so 30 meters. So now we know the speeds. So this is 20, and there is another train which is coming in the south, going toward the south direction with 30 meters per second. So velocity of train B with respect to A. So let us assume upward direction is positive. So velocity of B with respect to A will be velocity of B minus velocity of A, and that will be minus 30 minus 20, right? So that will be minus 50 meters per second. And velocity of the ground with respect to velocity of B. So velocity of ground with respect to velocity of B will be velocity of ground minus velocity of B, and ground is at rest, so that will be 0, minus velocity of B, that will be minus of 30, so that will be 30 meters per second. So in this question it should be given like which direction we have to take a positive, so I have taken upward as positive, and I'm getting option 3 as the right answer, right? Let us say this question, two cars are traveling towards each other at a speed of 20 meters per second each. When the cars are 300 meters apart, both drivers applies brake and the cars retard at the rate of 2 meters per second square. The distance between them when they come to rest. So let us see, again I'm going to solve this with relative motion. So there are two cars, and they're traveling towards each other. So it is coming in this direction 20, and this is the another car which is moving in the left direction with 20, and the distance between them is 300 meters, right? So let us let me call this car as 2, this car as 1. So let us study 1 with respect to 2. So with respect to 2, initial velocity of 1 with respect to 2 will be so I'm taking right direction as positive, So u1 minus u2, so u1 will be 20 minus u2 will be minus 20, so that will be 40 meters per second. Acceleration, so they are retarding, so the acceleration of 1 will be in the left direction and the acceleration of 2 will be in the right direction. So a1 acceleration of 1 with respect to 2 will be a1 minus a2, acceleration of 1 will be minus 2 and acceleration of 2 will be plus 2, right? It is in the right direction. So this comes out to be minus 4 meters per second square. So now we got the acceleration of 1 with respect to 2. So what should be the displacement? So they are, and finally, when they come to rest, final velocity of 1 with respect to 2 will be 0, right? Because both will come to rest. So we can apply the third equation of motion. So velocity of 1 with respect to 2 will be equals to initial velocity of 1 with respect to 2 plus 2 times acceleration of 1 with respect to 2 times displacement of 1 with respect to 2. So this will be 0 and it comes out to be 40 and acceleration is minus 4, so that will be minus 8. So this will be s of 1 with respect to 2. So it will be 40 by 8. So that will be a displacement of 1 with respect to 2, which is 5 meters. So it means so, sorry, it should be square. So I forgot to take the square. So it will be 40 square. So this comes out to be 1600 divided by 8, which will be 200 meters. So it means now the displacement, now the distance between, now the displacement of 1 with respect to 2 is 200 and the initial distance between them was 300. So the distance has decreased by 200. Now the distance between them when they come to rest is 100, right? Option 2 is the right answer. Okay, a passenger sitting in train A moving at 90 kilometers per hour observes another train B moving in the opposite direction for 8 seconds. If the velocity of train B is 54 kilometers per hour, then the length of the train B is, okay, let us see what we have given. Let us say this is the window from where the passenger is looking at the train B. Okay, so this is the observer. So when the, let us say, and they are moving in the opposite direction, right? So it is going in the left direction, train B is going in the right direction, right? So when the front of the train B is aligned with the window, then the passenger will start watching the train B, right? So I'm going to solve this problem again. I'm going to use a relative motion concept. So since the velocities are in the opposite direction, velocity of train B with respect to train A will be VB minus VA. So I'm taking right direction as positive. So VB is 54 and we have to find answer in meters. So let me convert 54. So 54 times 5 by 18. So that will be 3. So 15 meters per second and 90 can be converted as, so this will be 210. So it will be 25 meters per second. So VB is 15 minus of minus 25. So that will be 40 meters per second. Now we are observing with respect to A. So the train A will be at rest. And now when the rear of train B is aligned with the window, right, up to that point, that time the passenger will be able to see the train B. Okay. So what is the displacement of train B with respect to train A? It is nothing but the length of the train B. So let us say the length of the train B is L. So distance will be speed into time and time is given as 8 seconds. So we have to find L. So that will be 40 times 8. So it will be 320 meters. So 320 meter is the answer of this question. Right, let us say this question. Two balls A and B are placed at the top of 180 meters tall tower. Ball A is released from the top at t equals to 0 and ball B is thrown vertically down with the initial velocity of u at 2 seconds. After a certain time, both the balls meet 100 meter above the ground. Find the value of u. Okay, right. So let me show you the situation. So we have given a tower and its height is 180 meter. And we have released a ball A from the top at t equals to 0. And ball B is thrown vertically down with the initial velocity u at t equals to 2 seconds. So first let us find the state of ball A after 2 seconds. So after 2 seconds, it will acquire some velocity and its distance from the ground will decrease. Let us say the first ball reaches at this particular point B, or not B, let us take this point as C, and its velocity is V. So we can say V is equals to u plus at. We can u plus at. So u is 0, a is 10, and t is 2. So that will be 20 meters per second. So this will be 20. Now what is the displacement? So displacement will be half 10 t square. That is also 20 meters. So this displacement is 20 meters. Okay, right? So now we are throwing ball B with certain velocity u in the downward direction and at t equals to 2 seconds. And A is having a velocity in the downward direction which is 20 meters per second, and the distance between them is 20 meter. Right? So after certain time, both ball meet 100 meters above the ground. Suppose they are meeting at this particular point, 100 meters above ground. Right? So they meet at this particular point. So what is the so the distance, initial distance between them is how much? The initial distance between them is 20 meters, and the height, the distance of the first ball from 100 meter mark, this distance will be how much? So that will be 180 minus 100 minus 20. So that is nothing but 60 meters. Okay. So we know the displacement of the first of the ball A when both the ball meet at 100 meters above the ground. So we can find the time, right? We can find the time when they meet. So what is the time? So we can say, we can apply S is equal to ut plus half at square for the first ball. So S will be 60, u is 20 times t plus half, acceleration is 10 t square. Now from this we can eliminate 10. So it will be t square plus 40 minus 12 equals to 0. And this can be written as 6t minus 2t minus 12 equals to 0. So t comes out to be 2 or minus 6. So we can ignore negative value. So we know the time taken by the ball A up to the meeting point, right? So we know the time. So and the distance between these two balls is decreasing with the relative velocity. And what is the relative velocity? That will be u minus 20. So u minus 20 is the relative velocity, and speed is equal to distance upon time. Distance is 20 between them, and time is 2 seconds. So u is nothing but 30. So option D is the answer. Right. Now let us see this question. A boy reaches the airport and finds that the escalator is not working. He walks up to the stationary escalator in time t1. If he remains stationary on the moving escalator, then the escalator takes him up in time t2. So if we have a escalator, if it is at rest, the time taken by the boy is t1. But if the escalator is moving and the boy is at rest, the time taken is t2. If the escalator is, and we have to find the time taken by him to walk up on moving escalator. So let us say the velocity of the boy on a still escalator is v, and the velocity of the escalator is u, and this distance which the boy is covering is x. So t1 will be distance upon speed and t2 will be distance upon speed, and if both are moving then the velocity of the boy will be u plus v. So t3 will be distance upon speed. Now from these three equations we have to find t3. Let us eliminate x. So x can be written as x, u and v, nothing is given. So what we're going to do, let us find v, right? So v is x by t1 and u is x by t2, and from here we can find v plus u. So v plus u is x times 1 by t1 plus 1 by t2, and from this v plus u is x by t3. Now from this equation and from this equation we can find the relation between times. So x by t3 is equals to x by t1 plus x by t2. So 1 by t1 plus 1 by t2 is equals to 1 by t3. So t3 comes out to be t1 t2 divided by t1 plus t2. So option 3 is the right answer. Now let us see this question. A butterfly is flying with a velocity 4 root 2 meters per second in northeast direction. In this particular direction, 45 degree, right? With a velocity of 4 root 2. Wind is slowly blowing at 1 meters per second from north to south. So wind is blowing slowly from north to south in the downward direction. This is east, this is north, this is south, and this is west. And this is given as 1 meters per second, and the butterfly is moving in this particular direction with 4 root 2 meters per second. The resultant displacement of the butterfly. So the velocity of butterfly in ground frame will be velocity of butterfly with respect to wind plus velocity of wind, right? So which is nothing but, so let me call this as velocity of butterfly with respect to wind, and this will be velocity of wind. So vector addition of these two. So velocity of butterfly with respect to wind will be 4 root 2, and let us take the component, right? So 4 root 2 times cos 45 I cap. I'm taking right direction as x-axis, upward direction as y-axis. So that will be 1 by root 2 I cap plus 1 by root 2 j cap plus minus of 1 j cap. So this comes out to be 4 I cap plus 4 j cap minus j cap, which is 4 I cap plus 3 j cap. Now we got the velocity of the butterfly. So the resultant displacement, so the displacement will be, it is moving uniformly. So displacement will be v times t and vb times t, and this will be 4 I cap plus 3 j cap times the time, which is 3 seconds. So it will be, let us take the magnitude of this, 4 I cap plus 3 j cap times 3. So it will be, magnitude of 4 I cap plus 3 j cap is root of 16 plus 9 times 3. So it will be 5 times 3. So 15 meters. So option 4 is the right answer. Now let us see another problem type which is based on graphs. Right, so now let us see this question. Given below are two statements. Statement 1, area under velocity time graph gives the distance traveled by the body in a given time. And statement 2 is area under acceleration time graph is equals to the change in velocity in a given time. So in the light of the given statement, choose the correct answer from the option given below. Right, so if you look at the statement 1, it says if we have a velocity time graph, okay, suppose this is the velocity time graph, the area under this graph gives us the distance traveled, right? So it will be distance traveled if the particle is not changing its direction while moving, but if the particle is changing its direction, then it should give us the displacement, right, of the particle. So statement 1 is not completely correct, it is incorrect. So the right statement would be like the area under velocity time graph gives us the displacement covered by the particle. Now statement 2, area under acceleration time graph is equals to change in velocity in a given time. So if I draw acceleration time graph, let us say this is acceleration time graph, and if I find the area, so if I take a small strip, this is dt, and so we can say the area will be integral of a dt, and integral of a dt is nothing but integral of dv, which is change in velocity. So v final minus v initial. So that gives us the change in velocity. So statement 2 is correct. So the right answer should be statement 1 is incorrect, statement 2 is correct. So it should be 3, right? Right, now let us say this question based on graphs. The position time graph for two students A and B returning from school to their homes are shown in the figure. Right, so if you look at the graph for A, it starts this graph starts from the origin, and we can also see the displacement of A, right? And the time taken by A to reach school. A lives closer to school, okay? And if you look at the displacement of B, we can also see the displacement. Can you see the displacement of B is greater than displacement of A? And the time taken by B is less than the time taken by A. So that is the time taken by B, right? That much. And this is the time taken by A. And if you look at the slope of these two graphs, slope of so B is much more steeper, so we can say the velocity of B is greater than velocity of A. Now let us see the option. So A is given as the A lives closer to the school. Yes, yes, because it has covered less displacement, so A is correct. B lives closer to school, that is incorrect. A takes lesser time to reach home, so A is taking more time, so C is incorrect. A travels faster than B, that is incorrect. B travels faster than A, that is correct. So A and E are the correct statements, so option 1 should be the answer. Right, so let us see this question. From the VT graph shown the ratio of distance to the displacement in 25 seconds of motion. So whenever we have given velocity time graph, the area which is above the time axis will be taken as positive, and the area below the time axis will be taken as negative for displacement. But in case of distance, we have to add both the areas. So let us first find the area above the time axis. So here we have a trapezium. There are two trapezium, right? So for this trapezium, the area will be, let me call this as 1. So A1 will be half sum of parallel side, which will be 5 plus 10. And the distance between parallel side is 10. So it comes out to be 5 times 15, which is 75 meters. And A2, so this area will be A2. Again, half times sum of parallel side, which is 10 plus 20, and the distance between parallel side is 5, so it will be 15 times 5, so that is again 75 meters. Now the area of this triangle, which is 3, so it will be half base into height is 20, so that will be 50 meters. And let us find this area also below the time axis. So this is 4. So A4 is half, base is 20, base is 5 and height is 20. So that will be 50. So if we want to find the ratio of distance to displacement, so distance to displacement, so distance will be A1 plus A2 plus A3 plus A4. And displacement will be A1 plus A2 plus A3 minus A4. So it comes out to be 75 plus 75 plus 50 plus 50 divided by 75 plus 75 plus 50 minus 50. So that will get cancelled out. So in the numerator we have 150, 250, and in the denominator we have 150. So that will be 5 by 3. So 5:3 should be the answer. Option 3 is the right answer. Now let us see this question. A bullet is shot vertically downward with an initial velocity of 100 meters per second from a certain height. With 10 seconds, the bullet reaches the ground and instantaneously come to rest due to the perfectly inelastic collision. The velocity time curve for the total time. Okay, right. So the velocity time curve for the total time t equals to 20 seconds. So we know that after 10-second ball will come to rest and initial velocity was 10. So its speed will keeps on increasing, it is going down. Right. So we can use elimination. So if you look at option B, here the speed is decreasing. So option B is incorrect because it should increase up to 10 seconds. So here the initial velocity is 0. That is incorrect. We have thrown ball with certain velocity. Here again it slows down. So D is incorrect. So the correct answer should be option A, where first speed increases uniformly and then it becomes 0. And again it is increasing the negative x direction in negative y direction. So here we have considered upward direction as positive. So option A is the most appropriate answer. Now let us this question. The position, velocity and acceleration of a particle moving with constant acceleration can be represented by. So in when the particle is moving with constant acceleration, then acceleration time graph, like acceleration is constant in uniform accelerated motion. So if you look at all the options, we have acceleration as constant, right? And velocity time graph will be linear. It should be a straight line. And if it is accelerating, the speed should increase. So we can say this one is incorrect. This one is incorrect because it should be a linear graph. Now let us see, now we have to check for the position time graph. In case of a uniform accelerated motion, position time graph is parabolic. So option 2 is the correct answer. Now let us see this question. The velocity displacement graph of a particle is shown in the figure. It's a straight line, right? And the acceleration displacement graph of the same particle will be. So what we can do, let us first write down the equation of this straight line. So it will be v by v naught plus x by x naught equals to 1. So I have used like intercept form, and we have to find acceleration. So let us differentiate this. So it can be written as, if I differentiate this, v will become a, so a by v naught, and x will become v by x naught, and 1 will become 0. Now we can substitute v from the first equation. So v is nothing but 1 minus x by x naught times v naught. So let us substitute in this equation. So a by v naught plus 1 by x naught times, and we have v naught 1 minus x by x naught equals to 0. And from this, a by v naught can be written as v naught by x naught square times x minus v naught by x naught. Okay, now let us take this v naught on the other side. So it is a straight line. Can you see? This is the slope. That is the y-intercept. And y-intercept is negative and the slope is positive. So option 3 is the right answer. Now let us see this question. The velocity displacement graph describing the motion of a bicycle is shown in the figure. And the acceleration displacement graph we have to calculate. We have to find. Okay, right. So, so from this, we know that acceleration is v dv by dx, right? So can you see, if from 0 to 200 meters, velocity is increasing linearly. So this dv by dx is constant. So that is constant, right? So we can say acceleration will be directly proportional to the velocity. So velocity is increasing linearly. So A should also increase linearly. So option 3 and option 2 are incorrect, where we have a non-linear graph from 0 to 200 meters. Right? Now, after that, velocity becomes constant. So dv, so we can say dv by dx will become 0. So acceleration will become 0, right? So option 1 is the right answer, where first it increases linearly and then it will become 0. So option 1 is the right answer. Now let us see this question. Here we have given two columns. In column 1 we have given xt graphs, in column 2 we have given vt graph, and we have to match the columns. So if you look at A, here the slope is continuously increasing. It means the speed is increasing, right? And it looks like a parabolic function, and we know that when x is a parabolic function of time, then the velocity time graph will be linear. So we can say A corresponds to 2. If you look at the B, x is decreasing, right? So x is decreasing, so we can say speed is also decreasing because the slope is decreasing, right? The steepness of the slope is decreasing. So so if you look at option 4, that is that correctly represent this. So B corresponds to 4. And in C, first we have a linear graph up to a certain time, and then again linear graph. So so from, let me call this instant, from 0 to t1, position is increasing linearly, and so velocity will be constant, and it will be in the positive direction. But after that we have a negative slope, so it will be, velocity will also become negative. So option 3, so C corresponds to 3. Now for D, xt graph is linear, so dx by dt will be constant, so velocity should be constant, so 1. So D corresponds to 1. So let us see the option. So A is 2, B is 4, C is 3. So option 1 is the right answer. Now let us see this question. If the velocity time graph has the shape A and B, what could be the shape of the corresponding acceleration time graph? So A and B, so if you look at AM, we have a negative slope, and we know that dv by dt gives us acceleration. So if dv by dt is negative, so it will be negative acceleration up to a to m, right? So negative acceleration, and after that m to b acceleration, velocity is increasing linearly, it will be a positive acceleration. So option 2 is the right answer. First it is negative and then it becomes positive, and both the cases it is constant because the velocity time graph is linear. Now let us see this question. The velocity time graph of a body moving in a straight line is given by this graph. The ratio of the distance to the distance traveled by the body in time 0 to 10 seconds. So 0 to 10 seconds we have to calculate. So in order to find, we have done similar question, right, where the displacement, in order to calculate the displacement, the areas which is above the time axis, we'll have to take them as positive, and the area which is below the time axis we have to take them as negative. So let me name it. So let me call this as area 1, this is 2, this is 3, this is 4. So A1 is, it's a rectangle, so 8 times 2, 16 meters, and A2 will be 2 times 4, 8 meters. A3 will be 4 times 4, that will be 16 meters, and A4 will be 2 times 4, that will be 8 meters. So ratio of distance to displacement, so distance will be nothing but sum of all these areas, A2 plus A1 plus A2 plus A3 plus A4, and displacement will be A1 plus A3 minus A2 minus A4. So it comes out to be 16 plus 8 plus 16 plus 8 divided by A1 plus A3, that will be 16 plus 16 minus 8 minus 8. So the numerator will be what? It will be 48, and the denominator will be 32 minus 16, that will be 16. So it is 3. So 3:1. And we have to find displacement to distance. So displacement to distance will be 1:3. So option 4 is the right answer. Now let us see the next problem type, which is based on uniform accelerated motion in 2 dimension. So let us see the very first question. A particle starts from origin at t equals to 0 with a velocity 5 I cap meters per second and moves in the xy plane under the action of force, which produces a constant acceleration of 3 I cap plus 2 j cap meters per second square. If the x coordinate of the particle at that instant is 84 meter, then the speed of the particle at this instant will be √8. So at certain instant, the x coordinate is given as 84, and we have to find the speed of the particle at that instant. Okay, let me first write down the data. So at t equals to 0, we have given initial velocity, which is 5 I cap. and acceleration is given as 3 I cap plus 2 j cap. So by using this data, we can find the displacement, or let me find the displacement in the x direction, which will be u xt plus half a xt square. So displacement is given as 84 in the x direction. Initial velocity in the x direction is 5 times t plus half. Acceleration in the x direction is given as 3. Now from this equation we can find the time. So let us simplify this. It will be 3t square plus 10t minus 168. Okay, so we can say time will be minus 10 plus minus root 100 plus 4 into 3 times 168. So let me simplify this. So we have 12 times 168 plus 100, so it will be root of 1, so it will be 46. Okay, right, so 46 divided by 2a. So minus 10 plus minus 46 divided by 6. So let us take the positive one. So 46 minus 10 divided by 6, so that will be 36 by 6. So 6 seconds. So after 6 seconds, the x coordinate will become 84. Right? So now we have to find the speed. So vx, or let us find the velocity. So v is what? So v is equals to u plus at. So u is 5 I cap, a is 3 I cap plus 2 j cap, and the time is 6 seconds. So that will be 5 plus 18 I cap plus 12 j cap. So that will be 23 I cap plus 12 j cap, and we have to find the speed. So the speed will be the magnitude of this vector. So that will be root of 23 square plus 12 square, and that is given as root of alpha. So we have to find, so 23 square plus 12 square, so this gives us 673. So root of 673 is equals to root alpha. So alpha is 673. So that is the answer. Right, so now let us see the next question. The coordinate of a particle moving in the xy plane is given by this. So x is a function of time, y is a function of time. The motion of the particle is, so uniformly accelerated, having motion along a parabolic path, uniform motion, uniform accelerated, having motion along a straight line, non-uniformly accelerated motion. So let us find the acceleration, right? So we have given x. So let us find velocity in the x direction. So that will be 4. Then acceleration in the x direction will be 0. Now velocity in the y direction will be 3 plus 16t, and acceleration in the y direction will be 16. So if you look at this, the acceleration is constant, right? It is 16 j cap, or I can say, right, it's 16 j cap. So it is constant acceleration. So it's a uniform accelerated motion having, so having, or velocity, if you look at the velocity, velocity is initial velocity is in a plane, and the acceleration is in the y direction, right? So it means when we have velocity and acceleration in different direction, and like acceleration is constant, then we will be having a parabolic path. So option 1 is the right answer. Or if you want to prove in other way, you can also find the equation of trajectory. And how we can do that? We can eliminate time. So we have, so we can write t as x minus 2 by 4. We can substitute this in the second equation, which is y equals to 3 times x minus 2 by 4 plus 8 x minus 2 by 4 square. Now if you simplify this, it is a parabolic function. So option 2 is the right, option 1 is the right answer. So let us see the next question. Two buses P and Q starts from a point at the same time and moves in a straight line, and their positions are represented by xp, which is alpha t plus beta t square, and xq, which is ft minus t square. At what time both the buses have same velocity? So we can vp should be equals to vq. So it is nothing but the differentiation. So you have to differentiate xp with respect to time. You will get the velocity p, velocity of the bus p, and if you differentiate xq with respect to time, you will get the velocity of bus q. So if I differentiate that, alpha, beta and f are constants. So it will be alpha minus 2 beta t and q will be f minus 2t, and we have to find the time. So it is nothing but f alpha minus f divided by 2 times beta minus 1. So option alpha minus f, let me again check. Sorry, this is plus, right? This is plus, so this will be alpha minus f, and it will be minus of this, so it will be f minus alpha divided by 2 times beta plus 1. So option D is the right answer. Now let us this question. A body of mass 2 kg moves under force of 2 I cap plus 3 j cap plus 5 k cap Newton. It starts from rest, so initial velocity is 0, and was at origin initially, and even the position is 0 comma 0 comma 0. After 4 seconds, its new coordinates are 8 comma b comma 20, the value of b. So we can write, so we have to find the value of b. So what we're going to do, let us apply equations of motion in y direction, because b is the y coordinate of its new position. So we can say s is equals to sy equals to uyt plus half ayt square. So sy is b, and uy is 0, half ay. So force is given. So force divided by mass will give us the acceleration. So it will be 3 by 2, because mass is 2 kilograms. And time is given as 4 seconds, so 4 square. So this will get cancelled out. So it comes out to be 12. So 12 is the answer of this question. Now let us see this question. Position of an ant, which is s in meters, moving in the yz plane, is given by this equation. So s is equals to 2t square j cap plus 5k cap, and it is in seconds. Time is in seconds. The magnitude and the direction of the velocity of the ant. Magnitude and the direction of velocity after 1 second. So we know that ds by dt will give us the velocity. That will be 4t j cap plus 0. And after 1 second, it is nothing but 4 j cap. So velocity will be in the positive y direction. 4 j cap in the y direction. Sorry, this is option, so not second option, option 4 is the right answer. Right, so now let us see non-uniform accelerated motion in 2 dimension. So motion of a particle in xy plane is described by a set of the following equations. So x is equals to given as 4 sine pi by 2 minus omega t, and y is given as 4 sine omega t, and we have to find the path of the particle. So when we have to find the path, we have to eliminate time. So x can be written as, so the pi by 2 minus omega t, sine pi by 2 minus omega t is nothing but cos omega t. So that will be, x will be 4 cos omega t, and y is 4 sine omega t. Now we have to eliminate time. So we can write sine omega t as y by 4, and cos omega t is x by 4. Now we can square these two equations and add them. So the left hand side will become 1, and the right hand side will be x square by 16 plus y square by 16. So x square plus y square will be 16. So this is an equation of a circle which is having origin as the center, and the radius will be 4. So it's a circular path. Now let us see the next problem type, which is based on Riverman problem. So let us see a question. A person is swimming with a speed of 10 meters per second at an angle of 120 degrees with the flow, and reaches to a point directly opposite on the other side of the river. The speed of the flow is x meters per second, and the value of x to the nearest integer. Okay, let me draw the situation. So we have given a river, and the river is flowing in the right direction with a speed of x, right? And there is a person who is swimming at an angle of 120 degree with the flow. So this is the velocity of the person with respect to the river, right? And it reaches to a point directly opposite on the other bank. So it means the velocity of the person in ground frame will be along this line. So that will be Vp in ground frame, and this will be Vr. This is the velocity of the river in ground frame. So the resultant of Vpr and Vr will be nothing but Vp. And this angle is given as 120 degrees. So it means this angle will be 30 degrees. Now we have a right angle triangle where this angle is 30. This is x, and velocity of the person with respect to the river is given as 10. So that is 10 meters per second. Now we can apply trigonometry, and so sine 30 degrees will be x divided by hypotenuse, which is 10. So x comes out to be 5 meters per second. So that is the answer, right? Now let's see next question. A swimmer can swim with a velocity of 12 kilometers per hour in still water. So that is the velocity of the swimmer with respect to river, 12 kilometers per hour. Water flowing in river has a velocity 6 kilometers per hour. The direction with respect to the direction of the flow of the river water he should swim in order to reach the point on the other bank just opposite to its starting point. It is similar to the last question. So this is these are the banks, and this will be the velocity of the swimmer with respect to river, and this angle is theta, and this is velocity of the river, which is given as 6, and that will be the velocity of the swimmer, and it is given as 12. So this angle is alpha, let us say. So sine alpha will be 6 by 12, that will be 1 by 2. So alpha is 30 degrees. So theta will be 90 plus 30. So that will be 120 degrees. So 120 is the answer of this question. Now let us see this question. A swimmer wants to cross a river from point A to point B. Line AB makes an angle of 30 degree with the flow of river. Magnitude of the velocity of the swimmer is same as that of the river. So here we have given velocity of swimmer with respect to river same as velocity of river. Let me take it as u. The angle theta with the line AB should be so that the swimmer reaches the point B. Okay, right. So let me redraw the diagram. These are the two banks, and let us say this is the velocity of swimmer with respect to river, and that is the velocity of river, and this is the velocity of swimmer in ground frame. So this point is A, this point is B, and this angle is given as 30 degrees, and this angle is theta, which we have to calculate. This is u, and this is also u. And since VSR is same as VR, we can say this angle is also theta, right? And if you look at this angle theta, it is alternate angle, right? So theta and 30 are alternate angles. So theta is nothing but 30 degrees. So the answer will be 30 degrees. Now let us see the next problem type, which is based on like Rain Man problem. A girl standing on road holds umbrella at 45 degree with the vertical to keep the rain away. So he's keeping the umbrella at an angle of 45 degree. So it means the rain is falling in this particular direction where the velocity of the rain makes an angle of 45 degree with the vertical. If she starts running without umbrella with a speed of 15√2 kilometers per hour, the rain drop hits her head vertically. Okay, so velocity of rain with respect to the girl is in the vertically downward direction, and this is nothing but velocity of rain minus of velocity of girl in ground frame. So if this is the velocity of rain in ground frame, and this is the velocity of rain with respect to girl, so it means the girl velocity should be in the left direction, so that minus Vg is in the right direction. Only in that case we will get Vrg in the vertically downward direction, because Vrg is the resultant of these two vectors, right? Vr and minus Vg vector. So what we have given, velocity of rain is not given, but this angle is given 45 degree. So this is 45, this has to be, so this is 45, this is 90, so this is also 45. So this is also 45, right? So Vg is given, right? So Vg is 15 root 2 in magnitude, and we have to find the speed of the raindrop with respect to the moving girl. So Vrg we have to calculate. So in this right angle triangle, this is 45, this is 45, this is 15 root 2. So this has to be 15 root 2, right? So 15 root 2 can also be written as 30 by root 2. So option C is the right answer. Now let us see the next problem type, which is based on the projectile motion. So here first let us see the projectile from the ground. And let me quickly write down the important formulas that we have to keep in our mind. So if we are throwing a particle with the initial velocity u and the angle of projection is theta. So the time of flight is 2u sine theta by g, and the maximum height attained by the projectile will be u square sine square theta by 2g, and the range is u square sine 2 theta by g, and maximum range is u square by g, and it happens at theta to be 45 degrees. And the equation of trajectory, so there are two forms. So the first form is y is equals to x tan theta minus x square upon 2u square cos square theta. So the g is also there, gx square upon 2u square cos square theta. So this will be theta. And the second form will be y is equals to x tan theta 1 minus x by r, where r is the range of the projectile. And if we want to find the velocity, so velocity will be u cos theta I cap plus u sine theta minus gt j cap at a particular time. And if you want to find the position vector, that will be u cos theta t I cap plus u sine theta t minus half gt square j cap, right? So these formulas we have to keep in our mind. Now let us see some of the questions, right? So the particle moving in a circle of radius r with a uniform speed takes time t to complete one revolution. So time, right, so is given for a uniform circular motion. If this particle is projected with the same speed at an angle theta to the horizontal, the maximum height attained by it is equals to 4 times r. So h max is given as 4 times r, where r is not range, it is the radius of the circular path, right? The angle of projection is, so this will, so let us first find the speed of projection. So we have given time period for the circular motion. So time is distance upon speed. Distance will be 2 pi capital R upon u. So u will be 2 pi r by t. So this we have to use. So h max is u square sine square theta by 2g is equals to 4 times r, and u square can be written as 4 pi square r square by t square times sine square theta by 2g, that will be equals to 4r. So 1 r will get cancelled out. So from this we can find sine theta. So sine square theta will be 2g t square divided by pi square r. Now let us take the root of this. So theta will be sine inverse 2g t square divided by pi square r raised to power 1 by 2. So option 1 is the right answer. Now let us see this question. The maximum height reached by the projectile is 64 meters. If the initial velocity is halved, the maximum height of the projectile is. So we know that h max suppose if we're throwing the projectile in the vertically upward direction, it is basically uy square by 2g, where uy is the velocity in the upward direction. Now if the velocity is halved, since h max is directly proportional to square of the velocity in the vertical direction, right? So we can say if we halve the velocity, the h max will become 1/4. So 64 divided by 4, that will be 16. So 16 is the answer of this question. So in this case, we are projecting in the upward direction. There is no horizontal component. Let us see this question. The angle of projection for a projectile to have same horizontal range and maximum height is, so range and maximum height is given as equal, they are equal. Range is u square sine 2 theta by g, and h max is u square sine square theta by 2g. Sine 2 theta can be written as 2 sine theta cos theta, so it will be u square by g 2 sine theta cos theta is equals to u square sine square theta by 2g. So u square will get eliminated, g will get eliminated, 1 sine theta will get eliminated. So we can say tan theta comes out to be 4. So option 1 is the right answer. Now let us see this question. Given below are two statements. One is assertion, other is reason. Assertion is when a body is projected at an angle of 45 degree, its range is maximum. So that is correct. So for maximum range, the value of 2 theta should be equals to 1. So that is fine. So we can say both A and R are correct, and R is the correct explanation of A. So option 2 is the right answer. The equation of projectile projected from the ground is given by y equals to x minus x square by 20, where x and y are measured in meters. The maximum height attained by the projectile. Now we have to compare, this is the equation of trajectory. Let us compare this with the general form. So y is equals to x tan theta minus g x square upon 2u square cos square theta. Now if we compare the coefficient of x, so coefficient of x is given as 1. Here we have tan theta. So it means tan theta is 1. So theta is 45 degrees. Now let us compare the coefficient of x square. So 1 by 20 is equals to g by 2u square cos square theta. Right? And we have to find the maximum height attained. Now from this, I'm taking g as 10. So this will give us 10. So u square and theta is 45. So cos square theta will be 1 by 2 equals to 100. So u comes out to be 10 root 2. Now let us find the maximum height. So h max is u square sine square theta by 2g. So that will be 200 1 by 2 divided by 20. So that will be 10. So it comes out to be 5 meters. So option 1 is the right answer. Now let us see this question. Two projectiles A and B are thrown with initial velocity 40 and 60 meters per second at an angle of 30 and 60 with the horizontal respectively. The ratio of their ranges. We know that range is given as u square sine 2 theta by g. So and they have different velocities, so r is proportional to u square sine 2 theta. So we can say r1 by r2 will be equals to u1 by u2 square times sine 2 theta 1 by sine 2 theta 2, right? Let us substitute the values. So u1 is given as 40, u2 is given as 60. Sine 2 theta will be sine 60 degrees and sine 2 theta 2 will be sine 120 degrees. So this will give us 4 by 9. And sine 60 is root 3 by 2, and sine 120 is again, it will be root 3 by 2. Clear? And that comes out to be 4 by 9. So option 4 is the right answer. Clear? So okay, right. So now let us see the next problem. Two projectiles are projected at 30 and 60 with the horizontal with the same speed. The ratio of their maximum height attained by the two projectile. So we have to find the maximum height. So h max is given as u square sine square theta by 2g. For the same speed, h max is proportional to sine square theta. So h1 by h2 will be sine theta 1 upon sine theta 2 square. Sine theta 1 is sine 30 and sine theta 2 is sine 60. Square of that will be 1 by 2 root 3 by 2. So it will be square of that 1 by 3. So option 3 is the right answer. Now let us this question. The range of the projectile projected at an angle of 15 degree with the horizontal is 50. If the projectile is projected with same velocity at an angle of 45 degree with the horizontal, the range will be. Now we know that range, same velocity is given. So range formula is u square sine 2 theta by g. So for a given speed, range is proportional to sine 2 theta. So we can say R2 by R1 will be equals to sine 2 theta 2 by sine 2 theta 1. So we have to find a range when the angular projection is 45. So R1 is given as 50 meters and sine 2 theta 2. So that will be 90 degrees and 2 theta 1 will be 30 degrees. So R2 comes out to be 100. So option 3 is the right answer. Now let us see this question. A projectile is projected at 30 degrees with the horizontal with initial velocity of 40 meters per second. Velocity of projection at t equals to 2 seconds from the start will be. So we know that velocity is given as u cos theta I cap plus u sine theta minus gt j cap. So we're going to use this. So initial velocity is 40, the angle is 30, so it will be root 3 by 2 I cap plus 40 and sine 30 will be 1 by 2 minus 10 times 2. So this will be 20 root 3 I cap plus 20 minus 20 j cap. So it is 20 root 3 I cap. So the speed velocity of the projectile after 2 seconds will be 20 root 3. So option 1 is the right answer. Okay, right. So a projectile fired at 30 degrees to the ground is observed to be at the same height at time 3 seconds and 5 seconds after projection during its flight. The speed of projection of the projectile is in meters per second. Right. So if I show you the trajectory, suppose we have launched the projectile with initial velocity u and the angle of projection is 30 degrees and it is at the same height. Let us say this is the height, right? At 2 instants. And we have to find the speed of the projection. So let us say this height is h. So if you apply equation of motion in vertical direction, so sy is equals to uyt plus half ayt square, right? So from this sy is h and uy is velocity in the vertical direction. So u root 3 by 2, sorry, u times 1 by 2. Minus half g t square. Got it? So we got a quadratic in time. So from O to A the time is 3 seconds and from O to B the time is 5 seconds. So now from this it can be written as g by 2 t square minus u by 2 t plus h equals to 0. So t1 plus t2 will be minus b by a, that will be u by 2 divided by g by 2, and t1 t2 will be c by a, which will be h divided by g by 2. Now t1 and t2 is given to us, so 8 is equals to u by g and t1 times t2 will be 15, will be equals to 2h by g, right? Now from this equation we can find the speed of projection, which comes out to be 80. So u will be 80 meters per second, right? Now let us say this question, a body is projected from ground at an angle of 45 degree with the horizontal. Its velocity after 2 seconds is 20 meters per second. The maximum height reached by the body during its motion. So we have given angle of projection which is 45 degrees and we have given velocity after 2 seconds is 20 meters per second. So V is u cos theta I cap plus u sine theta minus gt j cap, right? So velocity is given as 20. So u, it will be u by root 2 I cap plus u by root 2 minus 10 times 2 j cap. Now its magnitude is given as 20 meters per second. So u by root 2 square plus u by root 2 minus 20 square, root of that is given as 20. So u square by 2 plus u square by 2 plus 400 minus 40 u by root 2 is given as 400. So this 400 will get eliminated. So we got u square minus 40 u by root 2 equals to 0. So u will be 0, or it can be 40 by root 2, or it can be written as, so we can ignore 0. So u comes out to be 40 by root 2 times root 2 by root 2. So that will be 20 root 2 meters per second. Now we know what is the speed of projection. So h max can be written as u square sine square theta by 2g. So u square will be 400 times 2, and sine square theta will be 1 by 2 divided by 20. So it gives us 20, right? So maximum height will be 20 meters. Now let us say this question. A fighter jet is flying horizontally at a certain altitude with a speed of 200 meters per second. When it passes directly overhead an anti-aircraft gun, bullet is fired from the gun at an angle of theta with the horizontal to hit the jet. If the bullet speed is 400 meters per second, the value of theta will be. So we have given a fighter jet, and when this fighter jet is overhead an anti-aircraft gun, a bullet is being fired, right, by the anti-aircraft gun. So it has a velocity of 200 meters per second in the right direction, and it is being fired at an angle of theta, and the bullet hits the aircraft. So this is the trajectory of the bullet, and somewhere here it hits the aircraft. Okay, so when this thing can happen? Only if their horizontal components are equal, right? Horizontal component of velocity components are equal. So if the velocity of projection of the bullet is v, so v cos theta should be equals to 200, and bullet speed is given as 400. So 400 cos theta is equals to 200. So cos theta will be 1 by 2. So theta will be 60 degrees, right? So 60 is the answer of this question. A projectile is launched at an angle alpha with the horizontal with a velocity 20 meters per second. After 10 seconds, its inclinations with the horizontal is beta. The value of tan beta will be, right? So let us see. So we have launched a projectile with initial speed of 20 meters per second at an angle alpha. And after 10 seconds, its inclination becomes beta. So this becomes beta and velocity becomes v. So we have to find tan beta. So first of all, we know in the horizontal direction there is no acceleration. So 20 cos alpha should be equals to v cos beta. And in the y direction, and this happens after 10 seconds. So if you apply equation of motion in y direction, so vy, which is v sine beta, equals to uy, which is 20 sine alpha minus gt, and t is 10 and g is also 10. So this will become 100, right? 10 times 10. So we got v cos beta, v sine beta. So v cos beta is 20 cos alpha, v sine beta is 20 sine alpha minus 100. And we have to find tan beta, right? So let us take the ratio of these two. So tan beta is 20 sine alpha minus 100 divided by 20 cos alpha. So this will give us 5 here. So it will be tan alpha minus 5 secant alpha. So 10 alpha minus 5 secant alpha, so option B is the right answer. A person can throw a ball up to a maximum range of 100 meters. So what is the maximum range? It is u square by g. So that is given as 100. How high above the ground he can throw the ball? So this will give us the max. So from this, we can find the speed of projection. So u will be what? It will be root of 1000. So with this speed, if you're throwing the ball in the upward direction, the maximum height will be, so we can, so that will be, so if you apply the third equation of motion, so final velocity will be 0, initial velocity is u minus 2a will be g times maximum height. So h max will be root 1000 square by 2g, that is 20. So 1000 by 20, so that will give us 50 meters. So option B is the right answer. Now let us see this question. A ball is projected from the ground with a speed of 15 meters per second at an angle of theta with the horizontal so that its range and maximum heights are equal. We have done the same question. The option D is the right answer. This the same question we have done, right? So you can do this as a homework. Answer option 3 is the right answer for this. Two projectiles thrown at 30 and 45 with the horizontal reach the maximum height in the same time. The ratio of their initial velocity. Okay, right. So they're reaching the maximum height in the same time. So it means the time of flight will be same. So T1 will be equals to T2. Because the time of ascent is same as time of descent, so we can say the time of flight will be same. So it will be 2u1 sine 30 degrees by g should be equals to 2u2 sine 45 degree by g. So 2 by g will get cancelled out. So u1 by u2 will be sine 45 by sine 30. So 1 by root 2 by 1 by 2. So that will be 2 by root 2 or it will be root 2. So root 2 ratio 1. So option 3 is the right answer. So if the initial velocity in the horizontal direction of a projectile is unit vector I cap and the equation of trajectory is this, y equals to 5x times 1 minus x, the y coordinate component of the vector of the initial velocity. So we have to find the y coordinates. So what we can do, so we have y is equals to 5x minus 5x square. So dy by dt will give us the y coordinate, that will be vy, and dx by dt is the x coordinate, which is given as 1. So if you differentiate this with respect to time, so dy by dt is equals to 5 times dx by dt minus 5 times 2x dx by dt. And initial velocity they're talking about, so x will be 0 initial for the point of projection. So this term will become 0. So 5 times dx by dt, which is 1, so it will be 5, right? So 5 is the answer of this question. A body of mass 10 kg is projected at an angle of 45 degree with the horizontal. The trajectory of the body is observed to pass through the point 20, 10. If t is the time of flight, then its momentum vector at time t equals to t by root 2. So if we want to find the momentum, we need to find the velocity, right? So once we know the velocity, we can multiply that with mass, we'll get the momentum vector. And it is passing through 20, 10. So an angle of projection is given. So let us use this formula. So let us use the equation of trajectory. So y is equals to x tan theta minus g x square upon 2u square cos square theta. So theta is given as 45 and it is passing through 20, 10. Let us substitute y as 10, x as 20. So y is 10, x is so y is 10, x is 20, and tan 45 is 1 minus 10, x is 20, so 400 divided by 2 times u square times cos 45 is 1 by 2. cos square 45 is 1 by 2. So from this, we will get 10 equals to 4000 by u square, or u square will be 400, or u will be 20 meters per second. Now we know the speed of projection, and we have to find the momentum vector at t equals to t by root 2, where capital T is the time of flight. Now time of flight is 2u sine theta by g, so that will be 2 times 20, and sine 45 is 1 by root 2 by 10, so this comes out to be 4 by root 2, or we can write this as 2 root 2. So that is the time of flight. So so t by root 2 is nothing but 2 seconds, so that is t. So what is the velocity after 2 seconds? So v is u cos theta I cap plus u sine theta minus gt j cap. So let us substitute the value. So u is given as 20, cos 45 is 1 by root 2, I cap plus 20 by root 2 minus 20 j cap. So we got the velocity. Now let us multiply this velocity with mass. It will give us the linear momentum or momentum vector. So it will be, mass is given as 10, so 200 by root 2 I cap plus 200 by root 2 minus 200 j cap. Okay, so let us simplify this. So 200 by root 2 will be common. Okay, right. So let me simplify this. Let us write, let us rationalize the denominator. So we can write this as root 2 100 root 2 I cap plus 100 root 2 minus 200 j cap. So that is the momentum vector. So if you look at the options, option D is the right answer. Now let us see the next question. A ball of mass m is thrown vertically upward. Another ball of mass 2m is thrown at an angle theta with the vertical. Both the ball stays in air for same period, so they have same time of flight, and the ratio of the heights attained by two balls is 1 by x. We have to find the value of x. So let us see both the situation. So we have given a ball and it is being thrown in the upward direction. Let us say it is being thrown with the speed u1, and there is another ball which is being thrown with the same say the speed is u2 and the angle of projection with the horizontal is theta. It is having a mass m, this ball is having a mass 2m, and we have given both the ball stays in air for the same amount of time, so it means the time of flight is same. So what is t2? So t2 is 2u2 sine theta by g. Now in case of the first ball, the time of flight will be 2 u2 by g, u1, sorry, not u2, it will be 2 u1 by g, and we have given that their time of flights are equal, so t1 is equals to t2, so we can say 2 u1 by g is equals to 2 u2 times sine theta by g. So g will get cancelled out, 2 will get cancelled out, so u1 by u2 is nothing but sine theta. So we got this relation and we have to find the ratio of the heights attained by the two balls. So let us do that. So h2 will be u2 square sine square theta by 2g, and h1 will be u1 square by 2g. Now if you take the ratio, so h1 by h2 will be u1 square upon u2 square sine square theta, and u1 by u2 is given as sine square is sine theta, so that is nothing but 1, so x will be 1, right? So that is the answer. Now let us the next question. Based on the same problem type, an object is projected in air with the initial velocity u at an angle theta. Okay, one thing I think I have taken theta with the horizontal, it should be with the vertical, right? So wherever I have written theta, it should be 90 minus theta. Let me correct that. So this should be 90 minus theta. This is also 90 minus theta. 90 minus theta. Okay. So we'll get the same answer even in this case. An object is projected in the air with initial velocity u at an angle theta. The projectile motion is such that the horizontal range is r is maximum. Another object is projected in air with a horizontal range half of the range of the first object. So when do we get maximum range? When theta is 45 degree. So in the first case, theta will be 45 degrees and we are getting maximum range. Initial speed is u. Now another body is projected in air with the horizontal range half. So let us say this is r1 and r1 is u square by g. So that is r1. Now the second body is being thrown such that we are getting half of the range. So this is r2 and r2 is r1 by 2. The initial velocity remains same in both the cases. So this particle is also projected with the same velocity. Initial velocity. The value of angle, okay, right, so it should be initial speed, right? Not velocity. Initial speed remains same in both the cases. So this angle will be theta. The value of the angle of projection at which the second object is projected will be, right? So R2 will be u square sine 2 theta by g, and that is equals to u square by g times 1 by 2. So u square by g will get cancelled out. So sine 2 theta comes out to be 1 by 2. So it means 2 theta is 30 degrees. So theta comes out to be 15 degrees. So 15 degrees is the answer of this question. Now let us see this question. A projectile motion of a particle of mass 5 grams is shown in the figure. The initial velocity of the particle is 5 root 2 meters per second and the air resistance is assumed to be negligible. The magnitude of the change in momentum between the point A and B is x into 10 raised to power minus 2, the value of x to the nearest integer. So we have to find the change in momentum between B and A. So just before hitting the ground, the speed will be same as the speed of projection. So here if the speed is 5 root 2, then just before hitting the ground the speed is also 5 root 2. So the final momentum, so I can say this is the final or momentum at B, which is making an angle of 45 degree with the horizontal. And we have to find change. So PB minus PA, that is the change, and this is PA, which is making an angle of 45 degree with the horizontal, and we have to find PB minus PA, which can be written as PB plus minus of PA. So minus of PA will be opposite to PA. This is minus of PA. Now the resultant of these two vectors, minus PA and PB, will give us the change in momentum. So this is the change in momentum delta P, and this angle will be 90 degree, right? This total angle will be 90 degrees. So delta P will be what? It will be 2 times say PA times cos 45 degrees, because PB and PA both have the same magnitude. So 2 times mass is 5 grams, so 5 by 1000 times the velocity, that will be 5 root 2. Cos 45 is 1 by root 2, so root 2 will get cancelled out. So this will be 50 by 1000, which will be 5 into 10 raised to power minus 2 kilogram per meter per second. So x will be 5. So 5 is the answer of this question. Now let us see this question. A stone is projected at an angle of 30 degree to the horizontal. The ratio of the kinetic energy of the stone at a point of projection to its kinetic energy at the highest point. So at the highest point, velocity is u cos theta, and at the point of projection velocity is u. So we have to find the ratio of kinetic energy at the point of projection, so which is half m u square to the kinetic energy at the highest position, which will be half m u cos theta square. So this comes out to be 1 upon cos square theta, and cos 30 is root 3 by 2, so that will be 4 by 3. So option 4 is the right answer. Right, now let us see this question based on the same problem type. Two objects are projected with the same velocity u, however at different angles alpha and beta with horizontal, and alpha and beta are complementary. The ratio of the horizontal range of the first object to the second object. So when we have if we are projecting particle with complementary angle, keeping the speed same, then the range will be same, right? So it should be 1:1. So option 4 is the right answer. Now let us see the next question based on the same problem type. The trajectory of the projectile in a vertical plane is given as y equals to alpha x minus beta x square, where alpha and beta are constants, and x and y are respectively the horizontal and the vertical distances of the projectile from the point of projection. The angle of projection theta and the maximum height attained are respectively given as. So let me rewrite the equation of trajectory. So that will be y is equals to x tan theta minus g x square upon 2u square cos square theta. So that is the general equation or general equation of trajectory. Now let us compare this equation with the given equation. So we can clearly see that tan theta is nothing but alpha, coefficient of x should be same, and coefficient of x square should also be same. So beta should be equals to g upon 2u square cos square theta. Now theta comes out to be tan inverse alpha. So it means option 2 and option 4 are incorrect, and we have to find the maximum height. And cos square theta is g upon 2u square beta. So h max is u square sine square theta by 2g. So this will be u square by 2g, and sine square theta is 1 minus cos square theta. So 1 minus g upon 2u square beta. So I have used this value, right? And tan alpha, tan theta is, okay, right. Maximum height you have to calculate, right? Tan alpha, right. So if you look at the option, it says alpha square by 4 beta. Let me first calculate that. Alpha square by 4 beta. So alpha square by 4 beta will be tan square theta divided by 4 beta will be g by 2u square beta g by 2u square, g by 2u square, and then we have cos square theta. So this will be how much? So this will give us 2. So it will be u square sine square theta by 2g, right? So it means option 1 is the right answer. Now that is another question. The maximum vertical height to which a man can throw a ball is 136 meters. The maximum horizontal distance up to which he can throw the ball. Similar question we have done, right? So you can, I'm keeping this as a homework. So if you do that, if you try to solve this, you will get option 3 as the answer. Okay, right. So for a body projected at an angle with the horizontal from the ground, choose the correct statement. So gravitational potential energy is maximum at the highest position. So that is correct. The horizontal component of velocity is 0 at the highest position. That is incorrect. It is u cos theta. The vertical component of momentum is maximum at the highest position. That is 0. So this is incorrect. The kinetic energy is 0 at the highest point of the projectile motion. That is incorrect. It is half m u square cos square theta. So option 1 is the right answer. Now let us see the next problem type where we are projecting particle from some certain height horizontally. So let us see this question. A ball rolls off the top of the stairway with a horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide, and the minimum velocity u with which the ball just hits the step 5 of the stairway will be root x meters per second, where x is. So we have given a staircase like this. Right, so we are throwing a ball horizontally with a certain velocity u, and this height is given as, so height of each step is given as 0.1 meter, and the width of each step is given as 0.1 meter, and we make sure this ball hits the fifth floor or fifth step. So that is the fifth step, right? So this one is the first one, this is second, this is third, fourth, and fifth, right? So what should be the minimum velocity? So if we are able to make sure this particle just hits this particular edge, okay, so we can say this will be the limiting case. So in this case, what is the horizontal displacement? We can say it will be 4 times, that will be 0.4 meters, and the vertical displacement will be 0.4 meters. Now what we can do in this case, we can use equation of trajectory in case of a projection from a height horizontally. And how we can do that? If I assume horizontal as the x-axis and vertical as the y-axis, then x can be written as ut and y can be written as half gt square. So if we eliminate time from these two equations, we will get the equation of trajectory. So y is equals to g x square by u square by 2. So that is the equation of trajectory. And if you look at this particular point, its coordinates are 0.4 comma 0.4. Now let us substitute these coordinates in the equation of trajectory. So it will give us 0.4 is equals to g, which is 10 by 2 times 0.4 square divided by u square. So this will get cancelled out, and this will give us a 5. So u square will be 2. So u will be root 2, and this is given as root x. So x is nothing but 2. So 2 is the answer of this question. Now let us see this question. Based on the same problem type, a body of mass capital M throws horizontally with a velocity u from the top of a tower of height h touches the ground at a distance of 100 meter from the foot of the tower. So we have given a tower, and we are throwing a ball of mass m horizontally with a velocity v, and the height of the tower is given as h. And right, so its distance, so the range touches the ground at a distance 100 meters from the foot of the tower. So that is the range for the first particle or first body. A body of mass 2m throws with a velocity v by 2 from the top of a tower of 4h, right, will touch the ground at what distance? Okay, let us see. So in case of a horizontal projection from the height, the range is given as the velocity of projection times the time of flight, which is 2h by g, right? So we can say the range is directly proportional to velocity and directly proportional to square root of the height of the tower. So we're going to use this. So we can say r2 by r1 will be equals to v2 times root h2 divided by v1 times root h1. So r2 we have to calculate. R1 is given as 100. v2 is v by 2. v1 is v. And h2 is 4 times h. And h1 is h. So this will give us 1. So range will be 100 meters. So there is no change in the range. It will remain same, right? So 100 is the answer. Now let us see this question based on the same problem type. A child stands on the edge of the cliff 10 meters above the ground and throws a stone horizontally with an initial speed of 5 meters per second. Neglecting the air resistance, the speed with which the stone hits the ground is. So height is given. So again, this question can be solved in multiple ways. So here you can also use energy conservation, because the stone is coming down by a height h. There will be a loss in gravitational potential energy, and that loss has converted into kinetic energy. So we can say half mv final square minus half mv initial square will be loss in gravitational potential energy, which will be mgh. So this we can apply. So m will get cancelled out. So we find, and we have to find the speed. So vf square will be equals to vi square times plus 2gh. So vi is 5 and g is 10 and h is 10. So it will be 25 times 200 plus 200, which will be 225, and root of that will be the speed just before hitting the ground, and it comes out to be 15 meters per second. So option 2 is the right answer.
If you find videos of this series useful, so it is highly recommended for you to join PracBee's revision program. So in this program, we're going to cover 10 blocks in 10 weeks, and we'll give you a target of 1 chapter per day, and we'll be able to cover all relevant chapters by the first attempt of JEE Mains. And how you can join this revision program? By clicking on the link given in the description. And one more thing you can do, please drop a comment. Let us know what else we can do for you to make this series better. Thank you.